Sir, good morning, sir.
రోజు రేపు చేద్దాం క్లీనింగ్ గేట్ ఓపెన్
పెట్టుకోండి.
అలాగే మేడం.
ఓకే సార్, పెట్టుకున్న తర్వాత ఇంకా మీరు ఇక్కడ ఆప్షన్స్ జూమ్ లో లాగిన్ అయ్యారు సార్. షేర్ స్క్రీన్ కి వెళ్ళంగానే మీకు విండోస్ అన్ని కనిపిస్తాయి. మీ పవర్ పాయింట్ ఓపెన్ చేసి షేర్ అనగానే వచ్చేస్తుంది. ట్రై చేయండి సార్. మీ దగ్గర ఇచ్చిండ్రా లేదా?
షేర్ స్క్రీన్ ఉంది మేడం.
మీ పవర్ పాయింట్ ని క్లిక్ చేసి షేర్ అనండి, వచ్చింది కదా సార్? వచ్చేసింది. అండ్ మీరు స్లైడ్ షోకి వెళ్తే స్లైడ్ షో కూడా వచ్చేస్తుంది సార్. ఇప్పుడు మీకేమో మామూలు మోడ్ లో ఉంది కదా, పవర్ పాయింట్ మోడ్ లో. స్లైడ్ షో పోతే స్లైడ్ షో కనపడుతుంది సార్.
అలాగే మేడం.
మీ టేబుల్ మీద నాకు ఇది ఒక్కటే ఇచ్చినారు. నేను కూడా నా మెయిల్లోకి తీసుకున్నా. We'll wait for few minutes, sir. Participants, మీరు సార్ వాట్సాప్ లో పెట్టండి సార్. Interested to join in. చేసేద్దాం. వస్తున్నారు 8 అయినా. మనకి సార్ నా సెల్ ఎక్కడ టెన్ 5కి స్టార్ట్ చేద్దామా?
10:05 స్టార్ట్ చేద్దాం.
సో మేడం ఓన్లీ ఆర్గానిక్ ఇంట్రెస్ట్ ఉండే వాళ్ళే అటెండ్ అవుతారు మేడం. ఇది అంటే సపరేట్ సెక్షన్ సార్.
ఇది ఆర్గానిక్ సెక్షనే కదా సార్ మొత్తం?
అలాగే మేడం.
అంటే ప్యారలల్ సెక్షన్స్ రన్ చేస్తున్నారు కదా సార్. ఆర్గానిక్ లో మనకి రిజిస్ట్రేషన్స్ పార్టిసిపెంట్స్ 32 అరౌండ్
అలాగే మేడం.
ఉన్నారు. అంటే మరి మార్నింగ్ నిన్న ఎందుకంటే 6:30 వరకు కూడా అయింది సార్. మనదే లేట్ అయింది, మిగతా వాళ్ళందరివి అయిపోయినాయి అంట సెక్షన్స్. కానీ ఆర్గానిక్ సెక్షన్ ది 32 కదా, ప్రజెంటేషన్స్ అవి టైం తీసుకున్నాయి.
అలాగే మేడం. జనరల్ గా ఆర్గానిక్ లో పార్టిసిపెంట్స్ కూడా ఎక్కువ ఉంటారు.
మనకి ఎక్కువ ఉన్నాయి. హలో సార్, మీటింగ్ పెట్టాలి కదండి 11:30కి. మీటింగ్ పెడితే నేను రాలేదు చెప్పాను. నేను రానని చెప్తాను, డిసైడ్ చేస్తారు. స్టార్ట్ చేద్దాం. పెట్టినారా సార్ అందులో మెసేజ్? So good morning everyone. Sir, able to hear me?
Yes madam.
Good morning everyone.
Good morning.
So a warm welcome to the day 2 program of this ICC 40th annual conference. So day 1 we finished with 2 invited lectures, CYSA presentations and some of the oral presentations. And today the day 2 program begins with the invited lecture 3 on oxidative couplings and annihilation strategies for the construction of privileged N heterocycles by Dr. K. Gopalaya, Associate Professor of Chemistry from University of Delhi. So just to introduce the speaker to the audience, sir obtained PhD from IISc Bangalore in the year 2005. He did postdoctoral research at the University of Paris in the year 2006 to 8. He was visiting scientist at University of Florida, USA. Sir published about 30 papers in reputed and international journals. His H index is 18 and number of citations is 1480. So 5 students awarded PhD under the guidance and then 4 students are working for their PhD. Sir is a recipient of Sudhir K. Banerjee Memorial Award from ICC in the year 2014. And sir also received Professor T. Bhaskar Reddy Excellence Award from SV University in the year 2016. So his research interests are CH bond activation and sustainable metal catalyzed oxidative annulations, and that we are going to hear from him today on the topic that is related to oxidative coupling and annulation strategies for the construction of privileged N heterocycles. Sir, we are very much grateful to you for accepting our invitation for delivering lecture on this topic. So thank you, sir, once again, and we welcome you for this conference, and I request you to proceed to take over.
Good morning, everyone. I thank Professor Leelavati Garu for kind introduction. I would take the opportunity to thank the organizers, Professor G.C. Saxena, President of ICC, Professor D. Ashok Sir, Vice President, Professor Rakesh Thakari, Secretary, Professor Leelavati Garu, Organic Chemistry Sectional President, for inviting me to deliver a lecture on the occasion of 40th Annual Conference of Indian Council of Chemists. My lecture today is concerned about a topic of current interest, oxidative coupling and annulation strategies for the construction of privileged heterocycles. Here is the outline of my presentation. I'll discuss brief introduction about oxidative coupling and annulation strategies, followed by exploration of oxidative coupling reactions in our laboratory. Further, I will focus on the utility of oxidative coupling reactions for the construction of 5 and 6 membered heterocycles, synthetic applications, reaction mechanisms for the newly developed approaches. Finally, I will conclude the results of my talk.
Sir, you can go for slideshow also.
Coupling reactions basically are 3 types. The first one is traditional coupling. It is a well-known and widely studied method. It involves the reaction between nucleophile and electrophile to produce the corresponding coupling for products. Grignard reactions, aldol condensations are the examples for the traditional coupling. The second one is the oxidative coupling. It involves the reaction of 2 nucleophiles in presence of catalyst and oxidant to produce the corresponding bond-forming products. Glaser-Hay coupling, Eglinton reaction are the few examples for the oxidative coupling. The last one is reductive coupling. Reductive coupling involves the reaction of 2 electrophiles in presence of catalyst and reductant to produce the corresponding bond-forming products. Pinnacle, Megumori reactions, acylane condensations are the few examples for the reductive coupling reactions. So in my research laboratory, we are working on the oxidative coupling reactions. In another couple of minutes, so I will discuss on oxidative coupling reactions. In this slide, I'll briefly discuss the difference between traditional and oxidative coupling reactions. 2 hydrocarbons directly undergo the oxidative coupling reaction in presence of catalyst and oxidant to produce the corresponding bond-forming products. So on the other hand, hydrocarbons need to be converted as electrophile and nucleophile for the traditional coupling. So this nucleophile and electrophile in presence of catalyst produce the corresponding bond-forming products. So for the traditional coupling reactions, traditional coupling reactions involves more reaction steps. On the other hand, whereas oxidative coupling involves the direct reaction. It is a one-step method. So this is the advantage in the traditional coupling and the oxidative coupling reaction. So nucleophiles are broadly classified in four groups. organometallic reagents, amines, alcohols, hydrocarbons, anions. Organometallic reagents produce large amount of byproducts in the reactions. Amines, alcohols, hydrocarbons. We have chosen these amines, alcohols, hydrocarbons because these produce simple byproducts such as water, hydrogen peroxide, ammonia. So, glacier coupling is the first example of oxidative coupling reaction. So, this was reported in 1869. So, it involves coupling of phenylacetylene, homocoupling of phenylacetylene in presence of copper 1 salt, base, and molecular oxygen, produce the bis-acetylene compounds. The mechanism of this reaction involves 3 stages. In the first stage, phenylacetylene reacts with the copper chloride in presence of base. It generates the corresponding organocopper. This organocopper in presence of molecular oxygen generates the corresponding phenyl acetylene radical. This radical undergo the dimerization, produce the bis-acetylene product. We have been working on aerobic oxidative coupling reactions using iron and copper catalysts. The general question is why iron or copper catalysts are important for oxidative coupling reactions. The answer is very simple. Iron and copper metals are relatively abundant in the earth crust. Iron and copper can bind and activate the molecular oxygen very well that perform variety of critical biological functions. So we have chosen benzyl amines as nucleophiles for the initial studies. We have screened various iron 3 salts as well as iron 2 salts for the conversion of benzylamine to N-benzyl benzaldamine in presence of molecular oxygen. We found that iron bromide was the best catalyst. It gave 95% yield of the N-benzyl benzaldamine completed in 3.5 hours. So we have synthesized a variety of imine compounds using iron bromide molecular oxygen protocol. As I have mentioned here, various benzylamines bearing electron donating groups, withdrawing groups, as well as naphthyl methylamine, by treating with iron bromide on molecular oxygen, furnish the corresponding N-benzyl benzaldamines in good to high yields. So ammonia is the byproduct in all these reactions. Heteroaryl methylamines also good substrate for this transformation. So it reacted with iron bromide and molecular oxygen, furnished the corresponding imine compounds in high yields. So aliphatic amines such as octylamine also furnish the corresponding imine compound in 53% yield. We also carried out the cross-coupling reaction between the benzylamine and the anilines using iron bromide oxygen protocol. It furnished the N-substituted benzaldamine products in high yields. So we have proposed the reaction mechanism for the formation of homocoupling product and cross-coupling product from benzylamines. Iron bromide undergo the oxidative addition with benzylamine in presence of molecular oxygen. It may generate the iron 3 complex. This further undergo the oxidation to generate the benzaldamine and regenerate the iron bromide for catalytic cycle. So this benzaldamine undergo the transamination with the benzylamine, furnish the homocoupling imine product. This homocoupling product in presence of aniline again undergo the transamination, furnish the cross imine compound. So this is the basic reaction in our laboratory. So after successful conversion of the carrying out the cross-coupling reactions for preparing N-aryl benzaldamines, we thought that if there are functional groups such as amine, hydroxy, mercaptan at the ortho position of the N-aryl benzaldamines, Such cross imines may undergo the intramolecular cyclization followed by oxidation, may furnish the benzimidazole, benzoxazole, and benzothiazole moiety. With this idea, we have screened various iron salts, and then we have synthesized a variety of 1,3-benzazole compounds. In the literature, biological properties of 1,3-benzazole compounds are well known. For instance, pentaprozole, omeprazole, mefafradil contain the benzimidazole moiety. Tafidamide, calcimycin, benoxaprofene having the benzoxazole core. Trilazole, jupalristat, merafraxine having the thiazole moiety. In 2019, Marsden group synthesized the two substituted benzoxazoles from benzylamines and orthoamino phenols using two catalyst. Two catalyst is a diruthenium complex and chemical DMBQ as a chemical oxidant at 150 degrees temperature. So we would like to synthesize a variety of 1,3-benzazole compounds using benzylamines and orthoseptanylines using iron catalyst. And as you can see here, we want to replace this complex ruthenium ruthenium catalyst with a simple iron catalyst, and we want to use molecular oxygen in the place of chemical oxidant. So we have synthesized a variety of 1,3-benzazoles. So various substituted orthophenyldiamines by treating with the benzylamines using iron bromide and molecular oxygen furnish the 2-aryl benzimidazole compounds. So orthoamino phenols by treating with benzylamines furnish the benzoxazole compounds. Orthomercaptonylines using benzylamines furnish the two substituted benzothiazole compounds in moderate to good yields. So we have studied the synthetic utility of our method for preparing the various biologically active molecules. This 2-thiophenyl benzimidazole was synthesized from orthophenyldiamine and 2-thiophenymethylamine using iron bromide and oxygen. This molecule exhibits the anti-leishmanial activity. The activity of this molecule is known in the literature. We have used our approach for synthesizing this molecule. So we have also synthesized a variety of benzoxazole compounds using 2-hydroxy 5-methyl anilines and various substituted benzylamines. So these benzoxazole compounds exhibit the anti-leishmanial activities. So we have proposed the reaction mechanism for the formation of 1,3-benzazoles from benzylamines. So, benzylamines converted to homocoupled imine using iron bromide and molecular oxygen. This I have discussed in one of the previous slides. So this homocoupled imine undergo the transamination with the orthosubstitute anilines may generate the cross-imine product, cross-imine intermediate. So this undergo the intramolecular cyclization followed by oxidation furnish the 1,3-benzazole products. So recently this article has been selected for the RSA Advances 10th anniversary collection, focusing on iron chemist toolbox. So this work also was highlighted by Largeren Group in their article. After successful synthesis of 2-aryl benzimidazole compounds from orthophenyldiamine and benzylamines using iron bromide oxygen protocol, so we thought that we can use higher homologue of benzylamine in the place of benzylamine. For instance, 2-phenylethylamine by treating with orthophenyldiamine and the same reaction protocol, iron bromide oxygen, furnish the 2-phenyl compound in moderate yield. So it is a new approach in the literature for preparing the quinoxylene compounds. So to improve the reaction yields, we have screened various iron salts and copper salts. We found that copper 1 bromide was the best catalyst. It gave 93% yield and reaction was completed in 6 hours at room temperature in presence of molecular oxygen. So we have using the copper bromide oxygen protocol, we have synthesized a variety of substituted quinoxylene compounds. As I mentioned here, various substituted 2-aryl ethylamines by treating with orthophenyldiamine in presence of copper bromide and molecular oxygen furnished the corresponding quinoxylene compounds. Heteroaryl ethanamines by treating with orthophenyldiamine furnished the corresponding 2 hetero substituted quinoxylene compounds in high yields. So we have also carried out the reaction with various symmetrically substituted orthophenyldiamines having the electron donating group and validator group, electron withdrawing group by treating with the 2-phenyl ethylamine using copper bromide and in presence of molecular oxygen at room temperature furnish the corresponding compounds. So further, we have studied the substrate scope using variety of unsymmetrical orthophenyldiamines by treating with 2-phenylethylamine in presence of copper bromide furnish the mixture of 2 regioisomers. So these isomers were isolated by column characterized by single crystal XRD and spectroscopic techniques. So we have also prepared a variety of biological active compounds using our novel approach. This para-hydroxy quinoxylene derivative with butyl cholinesterase inhibitor is an optyl derivative used for the treatment of platelet-derived growth factor-related disorders. This dimethoxy and dimethyl quinoxylenes inhibit the PGDF receptor kinase. So biological activities of these molecules are known in literature, but we have used our novel approach for synthesizing these molecules. So later we designed and developed oxidative coupling between indoles and benzylamines. We envisaged that indole may react with the homocoupled imine derived from the benzylamine. It may generate the 3 substituted in indole intermediate. This may break down to the 3-alkylidene intermediate. So another indole attack on the 3-alkylidene intermediate may furnish the bisindolyl compounds. So this article was selected in the thematic collection, Iron in Organic Synthesis. Initially, we have screened various iron salts and we found that iron triflate was the best catalyst in presence of molecular oxygen. Using iron triflate and molecular oxygen, variety of substituted benzylamines by treating with 2 equivalents of indoles furnish the aryl substituted bisindolyl methanes. So heteroaryl methanamines also react with the 2 equivalents of indole furnish the heteroaryl substituted bisindolyl methane compounds. Aliphatic amines such as hexylamine, octylamine, indoles furnish the corresponding bisindolyl compounds in moderate yields. So we also studied the reaction scope with a variety of indole derivatives. 5 substituted indoles, 2 substituted indoles, and 1 substituted indoles furnish the corresponding bisindolyl compounds in high yields. So using iron triflate oxygen protocol, we have synthesized a variety of biologically active compounds. This para-anisile derivative was synthesized from 4-methoxybenzylamine and indole. This inhibits the growth of colon bladder cancer cells. This hydroxy derivative inhibits the growth of lung pancreatic cancer cells. This tertiary butyl bisindolyl methane inhibits the human breast line cancer cell lines. So this work was highlighted by Lee group in 2017. So we designed and developed novel oxidative cascade reaction for the construction of quinozoline compounds. So we have chosen orthoaminobenzyl alcohol and benzyl amines by in presence of iron, bromide, and oxygen furnish the 2-phenyl quinozoline compounds. In these substrates, there are 3 nucleophilic functional groups, 2 amine groups, and 1 hydroxy group. So this undergo the cascade reaction to generate the 6-membered quinozoline compounds. So in the literature, by the biological properties of quinozoline compounds are known. Gefitinib, lepatinib, ecotinib, ellotinib, and many of these compounds having the quinozoline moiety, these are the anti-cancer agents. Linagliptin used for the treatment of type 2 diabetics. Prazosin is used for the treatment of high blood pressure and panic disorders. These have the quinozoline. So we have synthesized variety of quinozoline compounds. Various aryl ring substituted orthoaminobenzyl alcohols by treating with benzyl amines furnish the 2 aryl quinozoline compounds in high yields. So orthoaminobenzyl alcohols by treating with aryl as well as heteroaryl methenamines using in presence of iron, bromide, and oxygen furnish the 2 aryl and 2 heteroaryl substituted quinozoline compounds in high to excellent yields. So we have performed various control experiments for proposing the reaction mechanism. Benzylamine by treating with iron, bromide, oxygen furnished the homocoupled imine. This homocoupled imine reacted with the orthoaminobenzyl alcohols in presence of iron, bromide, and oxygen for 12 hours. Furnished the imino alcohol as well as oxygen intermediate along with the desired product. So we have also carried out the reaction between homocoupled imine as well and orthoaminobenzyl alcohol, but reaction was performed at room temperature for 2 days. It furnished the imino alcohol and oxygen intermediate. When 4-chloro-2-aminobenzyl alcohol was treated with the paramethoxybenzylamine using under the standard reaction conditions. So we observed the formation of iminoaldehyde along with the desired product. So based on these control experiments, we have proposed the reaction mechanism for the newly developed reaction. So benzylamine in presence of iron, bromide, and oxygen, it produces the homocoupled imine. This was discussed in the, and ammonia is the byproduct. So this undergo the transamination with orthoaminobenzyl alcohol may generate the imino alcohol. This will be equilibrium with the oxygen intermediate. This is known in the literature. And this imino alcohol undergo the oxidation to iminoaldehyde. This aldehyde captures the ammonia generated in the first step. So it is molecular economy. So and generate the diamine intermediate, and this undergo intramolecular cyclization followed by the oxidation furnish the 2-phenyl quinozoline compounds. So this work was highlighted in highlighted by Deshmukh in their research article. Further, we developed iron catalyzed oxidative annihilation of acetophenones with benzylamines. 2 equivalents of acetophenones by treating with benzylamine, 1 equivalent of benzylamine furnish the 2,4,6 triaryl pyridines. These are known as NOC pyridines. In these NOC pyridines, 2, 3, 5, 6 carbons are formed by the acetyl moiety of the acetophenone group, and the 4th carbon as well as nitrogen are coming from the benzylamine group. So I will discuss the mechanism in the coming slides. So the beauty of this that is the beauty of this reaction. So this again, it is atom economy. In the literature, 2,4,6 trisubstituted pyridines used for a variety of applications. For instance, these first four compounds exhibits the various biological activities. The last two are the OLED materials. So we have synthesized a variety of NOC pyridines using our method. So benzylamines bearing electron donating groups, withdrawing groups by treating with acetophenone derivative, two equivalents of acetophenone in presence of iron bromide oxygen under solvent-free conditions furnish the NOC pyridines in high to excellent yields. Heteroaryl methanamines react with the acetophenone furnish the 4 heteroaryl substituted NOC pyridines. We have also carried out the reaction with benzylamine with various substituted acetophenones using iron bromide and oxygen under solvent-free conditions. As you can see here, various complex 2, 4, 6 trisubstituted pyridine compounds were synthesized in our laboratory. So we have proposed the reaction mechanism for the formation of NOC pyridines from benzylamine. So benzylamine it generates the homocoupled imine in presence of iron bromide oxygen protocol. So enol of acetophenone react with the imine, it may generate the aminoketone, and this undergo the oxidation to aminoketone. This intermediate was isolated. This further react with another molecule of enol for generate the diketone. This capture the ammonia generated in the first step. It may generate the dihydro intermediate. So this undergo the oxidation to form the 2,4,6 trisubstituted pyridine. So this work was highlighted in the chemistry views in the year 2018. So we also designed and developed oxidative condensation of oxindoles with benzylamine for the construction of E3 alkylidene indole into ones. So various aryl substituted and N substituted indole into ones by treating with the benzylamine in presence of iron bromide and molecular oxygen at solvent-free conditions furnish the corresponding E3 alkylidene indole into ones. Simple two oxindole by treating with a variety of benzylamines furnish the corresponding 3 benzylidene oxindole derivatives in high to excellent yields. So using our novel protocol, we have synthesized a variety of biological active compounds. So this is the here I'm going to discuss about the preparation of tyrosine kinase inhibitor. So 2 oxindole by treating with 4 bromo benzylamine, it furnished the corresponding 3 alkylidene oxindole intermediate. And this further treatment with piperazine hydrogen chloride in presence of palladium acetate binap and cesium carbonate undergo the Buchwald-Hartwig amination, furnish the corresponding amine coupling product. So N formylation with the phosphorus oxychloride in DMF furnish the N formal derivative. So this is the tyrosine kinase inhibitor. So this is our key step. So we have synthesized variety of biological active compounds using our novel method. So this methoxy 2 oxindole by treating with trimethoxy benzylamine furnish the corresponding product. This is the anti-tumor agent. So oxindole by treating with piperanoylamine in presence of iron bromide furnish the corresponding product. It is an anti-covalent agent. Chloro derivative by treating with benzylamine furnish the corresponding chloro alkylidene intermediate. This is tyrosine kinase inhibitor. So biological activity of these compounds are known in literature. We have synthesized by our approach. So we have proposed the reaction mechanism for the formation of 3-alkylidene oxindoles from. So oxindole undergo the enolization. This enol undergo the oxidative addition with iron bromide in presence of molecular oxygen. Initially, it may generate the iron 3 complex. So this acts as a nucleophile to react with the imine compound derived from the benzylamine. It may generate the 3 substituted intermediate through this 6-member transition state. This breakdown to the 3-alkylidene oxindole and benzylamine and regenerate the iron bromide for catalytic cycle. This article was selected in the special issue iron in organic synthesis. So I'll conclude my talk. Using oxidative coupling and annihilation strategies, we have synthesized a variety of heterocyclic compounds, 1,3-benzazole compounds, bisindolyl methanes, quinoxaline compounds, quinozolines, 3-alkylidene 2-oxindoles, nocpyridines, benzoyl derivatives, and aminoacridine derivatives. So it is an interesting quotation about iron by Carsten Baum Research Group. More and more chemists are now working with iron catalysis and are finding it more rewarding. Finally, I thank my PhD students and funding agencies, DST, CSIR, and University of Delhi. I thank for your kind patience.
So thank you, sir. Any questions from the participants? Participants? Anybody wants to interact with participants? Sir, presentation is very interesting. Sir, one question. So just now you said from Indole, I think, sir. This is you published in JOC that paper where tyrosine kinase inhibitor. Yes. So here, yes, this is basically is it alkylidene benzylidene derivative or loss of amino group is involved, sir? Here, reaction of this with 1 and 2 bromobenzylamine.
Okay, madam.
So the ammonia group is lost here.
Yes, madam. Ammonia group will be lost.
Ammonia group is lost. So yes, that is again catalyzed by this iron bromide only.
Yes, madam. Yes.
It's lost as ammonia.
Yes, madam.
Okay. So interesting, sir. That is.
Yeah, actually, I have shown the mechanism how the ammonia will be, loss of ammonia in the first slide.
Common one. Okay.
Yeah, I'll show you.
Mm-hmm.
Yeah. Yeah, this one.
Okay, sir.
So here ammonia will
that is okay, sir. Because I didn't link this with that one.
Yes,
okay,
madam.
so
actually,
I was concentrating on that.
We have designed
okay.
2-3 methods to trap this ammonia.
Okay.
And this ammonia nitrogen is again a part of the heterocycle, and water will be the only byproduct. So I see here. I will just show you some of the slides. So it is we develop very interesting reaction. Yeah, you can see here. So this benzylamine initially generate the ammonia, and again this ammonia will be the generated ammonia trapped by this alcohol group. I will show you the here this one. So you can see here in the first step ammonia is liberating.
Okay.
So it is of course it is not the byproduct here. This ammonia again trapped here. So
Okay.
when this alcohol is converted to aldehyde, this
Okay, converted into imine.
ammonia generated.
Okay.
And then whatever this ammonia liberated, that will be a part of
Used up.
Yes,
Okay.
madam. And only water is the byproduct.
Byproduct. It's very interesting, sir. I think like it's something green chemistry.
Yes, madam. Yes.
Utilizing
Like that,
maximum.
I have designed 2-3 projects, madam. Trapping of ammonia. Yeah.
Okay. So anybody from participants? Anybody from participants? Okay, sir. If because you are also busy with some personal personal work. So if no other questions from the participants, so we thank Dr. Gopalaya garu. Sir, thank you very much, sir, for giving us time in explaining the oxidative coupling and annihilation strategies for the construction of privileged N heterocyclics. We are very much grateful to you, sir, for sparing your precious time in enriching the participants with the knowledge on this oxidative coupling and construction of heterocyclic reactions. Sir, clearly it is very interesting and informative, sir. So actually, this is, you started with differentiating what is the traditional coupling and then oxidative coupling, and then went on to explain the role of the simple common catalysts like iron and copper in construction of oxazoles, thiazoles, and quinoxalines. So once again, we are very grateful to you, sir. So thank you very much, sir, for your presentation. Thank you so much, sir.
Thank you so much.
So, Ashok, sir.
Madam,
Sir,
oral presentations.
Okay, sir. Sir, we finished the lecture, sir's lecture. Okay, sir. Thank you, sir. Thank you so much.
Thank you, Professor Ashok, sir. Thank you, madam.
Thank you very much, sir, for
Thank you.
sparing
Thank
your
you,
valuable
sir.
time
Thank you, madam.
and presenting very nice work.
Thank you, sir.
Nice and simple.
Thank you, sir. Thank you, sir.
Sir, thank you, sir. We look forward for more such interactions also.
Thank you,
Thank you,
madam.
sir. Once again. Right. Sir. So the next we'll go ahead with the oral presentations. Starting ఇప్పుడు వస్తా సార్ ఒక 5 minutes ఇది just announcement. I think we are supposed to start from presentation 16. Aparna. ఇప్పుడే వస్తా సార్.
Madam, good morning, madam.
Yes.
Ready for presentation? Aparna, you can share.
Yes, madam. Good. Yes, madam. Good morning, madam. Yes, madam.
Please share your screen.
Yes, sir. Yes, sir. Good morning, sir.
Very good morning.
ఇదేంటి బ్యాక్గ్రౌండ్ అట్లా వచ్చింది
పిల్లలు ఎవరైనా సెట్ చేసుకుంటారు
ఎట్లా ఉంది
పిపిటి
డెస్క్టాప్
Yes.
Yes, sir. Sir, is it visible, sir?
Yes, it will be visible.
Yeah.
Yes.
Yeah. Very good morning to respectable Ashok, sir. Our HOD, Professor Umesh Kumar, sir. BOS, Professor Leelavati, madam. My supervisor, guide Sharda, madam, and Subhashini, madam. A very good morning to everyone, and thanks for giving this opportunity, particularly ICC, Satavahana University. And this is our presentation, sir. We are from the Department of Science and Humanities from Matrusi Engineering College, from Chemistry Department. Myself, Dr. Y. Aparna, and my colleagues, Mr. T. Vishnu, Mrs. K. Sandhya, and Mrs. Aruna Kumari. So we have done the molecular docking studies of novel imidazolones against fungal proteinase and SARS-CoV-2 main protease. And as we know that imidazolones are prepared, imidazolones are the heterocyclic compounds, and they play crucial role in drug discovery process and exhibit various biological functions. They possess broad spectrum antibacterial activity, antifungal, and anti-cancer activity. They are also the precursors for the synthesis of monoamino oxidase inhibitory agents. And we have prepared a new series of imidazolones. And this is the known method, but we have used a starting material which is not reported with so many moieties, like we have used 2-hydroxypuric acid. And we have prepared the imidazolones by condensing azolactones with various substituted amines in presence of Wills-Meyer hack reagent, that's POCl3 and DMF. This acts as a cyclodehydrating agent, and different azolactones were prepared by the Erlen-Meyer method, starting from 2-hydroxypuric acid and substituted aldehydes with a catalytic amount of sodium acetate and acetic anhydride. And these compounds are actually already prepared, and they were analyzed with different analytical techniques like NMR, C13, proton NMR, IR, and mass spectroscopy. And we have used the 4.2 autodock for the molecular docking studies on the fungal protein, aspartic proteinase, and anti-COVID protein, that's SARS-CoV-2 main protease, by using the PDB ID as mentioned in the PPT, 2QZW and 6L user, that is downloaded from the protein data bank. And we already knew that these imidazoles have all the activities like antifungal, anti-cancer, anti-inflammatory, neuroleptic, sedative, anti-diabetic, and anti-obesity. We have carried the in vivo studies and in vitro studies for the antifungal activity, but for the anti-COVID, it is just the docking studies that were performed, and they were not done on the wet studies. And because we have chosen these imidazolones because of their scope in their pharmaceutical industry, like this imidazolone ring used in your losartan, it is one of the moiety, then cimetidine and metronidazole. And this is the scheme that we have prepared as a routine method, but we have used the starting material, which is different, and we have used Wills-Meyer hack reagent. So we have started with this benzoyl glycine, which is your 2-hydroxypuric acid on benzylation, followed by the reaction with aromatic amines. So substituted aromatic aldehydes we have taken and condensed, refluxed for about 2 to 3 hours using sodium acetate and acetic anhydride. Around 11 compounds were synthesized by taking different aromatic substituted amino acids. And after preparation of these azolactones, we have use this Wills-Meyer hack reagent, which is maintained at 0 to 5 degrees centigrade temperature, the preparation of Wills-Meyer hack reagent, followed by reflux for about 2 to 3 hours, and temperature condition maintained around 100. And we've used 2 different aromatic amines, aniline and para-amino acetophenone on these, and we have synthesized novel compounds, 11 imidazolones. And these are the 11 imidazolones which we have synthesized using aniline and para-amino acetophenone. And here is the NMR spectra for that. The acyl proton around 2.3 and the aromatic protons around 7.3 to 8. And here we have the C13 NMR. We have the significance cardinal group around 161 to 166. And the mass spectrum is 471. That is the M+1 for the compound as one of the representative derivative. We have taken this example. And this is the CHN analysis, where the analysis that we have carried out was matching with the CHN analysis that was calculated, and the calculated and found results were matching. And these are the antifungal results that we have performed in wet studies. So we have carried the antifungal studies on Fusarium ricini and Candida albicans. And here we have gone for the molecular docking studies on aspartic proteinase. The protein data ID that we have taken from the protein data bank is 2QZW, and we have gone for the docking studies. One of our colleague, Mr. Vishnu, has helped us in these docking studies. He has performed docking studies on this antifungal protease, the aspartic proteinase, as well as the SARS-CoV proteinase. And it was found that this moiety is showing 1, 2, 3 hydrogen bond interactions with aspartame, arginine, and thiosin. And this hydrogen bonding interactions can be seen clearly on the different sites. And it has shown 3 hydrophobic interactions. So this side of the moiety, where you have the chlorobenzene moiety, and here also there are 2 interactions this side and the other interaction over this side. So it is showing 4 hydrogen bonding interactions and 3 hydrophobic interactions. Maybe this is for better binding of the drug receptor interaction that we have cited for. And these are the binding energy results, where the compound number 5, I have shown this compound number 5 here. This compound number 5 here, 3, 4. This is carried on nitro. Yeah, we've carried on the chloro derivative. So chloro derivative of our imidazolone, we have carried the docking studies, and the docking studies, it was observed that this chloro derivative has shown the highest binding energy of minus 12.01. And there are 3 hydrogen bondings for this. No, it is not aspartic protein. I'm sorry, this is the aspartic protein. It has shown minus 11.07 as the binding energy. And it has shown 3 hydrogen bonding interactions and 3 hydrophobic interactions. And this is the docking pose for the aspartic protease of the antifungal activity. And this is our data, that is binding energy data for the amino acid of SARS-CoV-2 main protease. This is the only docking studies that we have performed based upon the structure and the interaction, binding interaction studies with the protease. So almost all the compounds have shown good binding interactions. The highest interaction was shown by this compound, where we have the bromo derivative as a amino group. I mean, the aldehyde, bromoaldehyde, which we have taken, has shown the highest binding, that is minus 12.01 kilocalorie per mole. And it has shown 3 hydrogen bonding interactions and 2 hydrophobic interactions with the amino acids. 3 hydrophobic interactions and 3 hydrogen bonding interactions. And our scope of study is to, because of its multifunctionality in heterocyclic chemistry and its scope as a CNS agent, that is your CNS depressant agent, anti-cancer agent. Now, the SARS-CoV, which is in demand, or which is in particularly under study, we have tried on this SARS-CoV-2, even though the molecules are already reported by us in already a particular journal, but the studies were not reported. The fungal studies and the antifungal studies, as well as the SARS-CoV-2 studies, were not reported in any of the paper. This we have carried out using AutoDoc 4.2. And these are the references. And we have seen that the interactions of the compounds with the amino acids of fungal protein, as well as the SARS-CoV-2 protein, which I've already shown in the tabular column. Thank you, sir.
Any questions from participants?
मैं ऊपर जा रही हूँ.
Yes, ma'am. Participants.
Participants, any questions?
Screen and not screen.
Okay, if there are no questions, thank you very much, Aparna madam, for
Thank you so much, sir, for giving me the opportunity.
And, excellent work, and especially
Thank
you
you,
have done some work on COVID-19, and
Yes, sir.
very nice presentation. Nice work. Thank you.
It was a collaborative work, sir. Thank you so much.
Oh, okay. Nice, nice.
Thank you, sir.
Next presentation, OO 17.
Yes, sir, present.
Who is going to present?
Mamta Sangole.
Okay. Please share your presentation.
Sir, is it visible?
Pardon? Okay.
Yeah.
Okay.
Okay. Can you see my presentation?
Yes.
Okay. Good morning, everyone. I'm Dr. Mamta Sangole, presenting the paper entitled Carbohydrate Structural Elucidation by Mass Spectrometry. As we know, carbohydrate chemistry has been found to be one of the most frontier areas of research due to its wide range of applications in the field of pharmaceutical industry. And also, the pharmaceutical industry, the recent literature is enriched with the progressive findings about the synthesis and pharmacological actions of sugar heterocycle. Therefore, design and development of novel N and S glycosides have emerged as an important class of compound. These are the contents of my presentation. Hence, we have designed several sugar heterocycles, such as the formation of 1-hepta-O-benzoyl beta-D-maltosine 3-aryl thiocarbamides by the interaction of 1-hepta-O-benzoyl beta-D-maltosyl thiocyanate with the various aryl amines. And the analysis of newly synthesized derivatives have been investigated by the various spectral techniques. And one of the most widely used and important techniques is mass spectrometry. This analysis method described in this paper demonstrate the structural characterization of sugar derivatives based on their molecular mass as well as the mass of their respective fragments ion using the mass spectrometry. Basically, the mass spectrometry was first applied to the carbohydrate analysis in 1958 with electron impact ionization. EI is only suitable for the organic molecule, but hydroxyl group in non-volatile molecule in carbohydrate had to be protected by permethylation or per-acetylation or per-benzolation to increase the volatility prior to analysis. Since then, many researchers for structural analysis of sugar using the mass spectrometry have been reported with the improvement of analytical techniques. The development of soft ionization method such as FAB, ESI, RD, which enables the native carbohydrate to be ionized with the molecular ion information to be obtained. FAB has been introduced in 1981 and was the first ionization method used in mass spectrometry experiment of carbohydrate. A mechanism of FAB is similar to EI. Instead of impacting the sample by electrons, FAB uses the beam of atoms. Sample has to be analyzed in the liquid matter. So currently, FAB has been replaced by later development methods such as RD and ESI. In reaction scheme, you can see when the interaction of 1-hepta-O-beta-D-maltosine isothiocyanates and aniline has been carried out in benzene medium for 3 hours. And the solvent benzene was distilled off and the sticky residue obtained was titurated with the petroleum ether to afford a granular yellow color solid. This was crystallized by ethanol and water. And the elemental analysis assigned the molecular formula of the product C16H15O17N2S. when the interaction of hepta-O-beta-D-maltosine thiocyanate was extended with the several amines, other and related 1-hepta-O-benzoyl beta-D-maltosine 3-aryl thiocarbamides have been isolated. And the mass spectra of these products were acquired by the FAB mass spectrometry to understand the compositions and fragmentations of sugar molecule. And some of the mass spectra of this product, sugar thiocarbamides, are listed below. Here we have a mass spectrum of various synthesized products, and you can see the mass spectrum of the product shows the molecular ion peaks as well as the other fragments. So you can see these are the mass spectrum of the synthesized product, and here we have listed the molecular ion peaks as well as the other fragments obtained from the mass spectrometry. So the conclusion of this work is that in a summary, we can say that we must say the mass spectrometry is a widely applied method in structural analysis of carbohydrate, and due to its high sensitivity and capability of providing the details molecular information, however, obtaining the full level of structural information such as sugar identity, anomeric configuration, linkage position, sequence, and branching location has not been possible by mass spectrometry. But the molecular weight determination and composition information of carbohydrate is readily obtained from the soft ionization method such as ESN and MALDI. So this is all about the structural analysis of carbohydrate with the help of mass spectrometry. So these are the references.
Sorry, sir.
Thank you very much, and thank you ICC team for giving me a chance to present my work.
ఏం లేవు ఈ బొమ్మకు టెడ్డి పేర్లు ఉన్నాయి కదా నన్ను అవే కనపడి
డిఫరెంట్ కలర్ కనిపిస్తున్నాయి
లైట్
Any questions from participants?
ఒక్కొక్క డాట్ ఒక టెడ్డి పేరు ఒక డాట్ ఒక టెడ్డి పేరు సో రెడ్ కలర్ కి ఎక్కడ చూస్తే ఆ కలర్ దగ్గర
Any questions from participants?
అని సార్ మళ్ళా కనెక్ట్ చేసి
Thank you, Dr. Mamta T. Pangodi. Samdole, nice presentation and nice work.
Thank you, sir.
Do you have mass instrument at your place?
No. So, sir, we have analyzed our product at CDRI Lucknow. We don't have facility at our place.
Are they charging for recording mass spectrometry?
Yes, sir. At that time, the charges was very low, but recently, I think the FAB has not working in CDRI Lucknow. So we will go for Hyderabad for analysis.
Okay. Nice. Who is Professor Deshmukh, sir?
Yes, sir. I'm a student of Dr. S.P. Deshmukh, sir, and we met, sir, so many times at Hyderabad as well as in many conferences.
Okay. Nice. Thank you very much, madam.
Sir, thank you.
Next presentation, 0019. Author is Mega GV. Hello. Is it Mega GV?
Sir, I am available, sir.
Start sharing the screen, please.
Hello.
Hello.
Start sharing the screen. Yeah, you are available. You can start sharing the screen. Start your presentation. Mega.
Okay, okay, ma'am. Okay.
प्लास्टिक लाई थी क्या? ये लाई थी वो.
Hello.
Gopal 50 minutes lane చెప్పిండు 35 సింపుల్ గా సార్ బాగుంది అంటే లోడింగ్ లేదు పక్క సింపుల్
మంచి పేపర్స్
అంటే వర్క్ రీసెంట్ గా సార్ ఇప్పుడు ట్రెండ్ ఆక్సిడేటివ్ కప్లింగ్ అంటే అందులో సింపుల్ గా ఎట్లా అన్ని ఐరన్ కాదు కదా దాంతోనే చేస్తారు
ಎಲ್ಲಿದೆ ಅದೇ ತಾನೇ ಇರೋದು
ಸ್ಟಾಪ್ ಮೇಲೆ ಇದೆ ಬಿಟ್ಟು ಬೇರೆಯವ್ರದ್ದು ಇಟ್ಟಿದ್ಯಾ ಅದ್ರ ಮೇಲೆ
सीमा
ಸ್ಟಾಪ್ ಮೇಲೆ ಇದೆ
ये बंद चला गया.
ಇದೆ 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 ಅದು
ವರ್ಡ್ ಫೈಲ್ ಇದೆ ಇದು
ವರ್ಡ್ ಅಲ್ಲೇ ಮಾಡಿರೋದಿದೆ
ಇದೇನಮ್ಮ
Mega, what happened? Okay.
Hello.
My
Yeah,
presentation
start the
principal ಅಂತ
presentation.
ಕೇಳಿ
Hello, ma'am. My presentation is available now.
Yeah, it's visible now. It's visible. I think you can start.
ಸ್ಟಾರ್ಟ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಕೊಡಿ
Hello. Good morning. Hello. Good morning to everyone.
नहीं
Hello. Good morning to everyone. Myself Megha GV, scholar from Kuvempu University. I am going to present oral presentation titled Synthesis of Biphenyl Tetrazole Derivatives. These are the contents: introduction, present work, characterization, biological evolution, conclusion, and references. This is the introduction. As we all know, tetrazoles are the 5-membered heterocyclic compounds containing 4 nitrogen atoms and 1 carbon atom. The tetrazole moiety is versatile lead molecule in the pharmaceutical development and has wide range of biological applications. The compounds containing tetrazole nucleus find unique place in the medicinal chemistry and pharmaceutical chemistry as they are associated with immense biological activity. The biphenyl tetrazole compounds from the backbone of a number of known antihypertensive agents. Commonly, tetrazole backbone belong to group angiotensin receptor 2 angiotensin, which are generally referred to associated with show biphenyl tetrazole backbone include candestatone, irbesartan, losartan, olmesartan, valsartan. Based on that literature reports, we have synthesized some biphenyl tetrazole derivatives and characterized using techniques such as IR, NMR, and MAS. Further, we have screened the synthesized compounds for their antibacterial and anti-TB activity. The molecular docking study was also carried out for the synthesized compounds. This is the reaction scheme. Here, 4-bromo-biphenyl methyl triphenyl tetrazole is reacted with benzocaine in the presence of acetonitrile and K2CO3 as catalyst maintained in the reflex condition. We obtained intermediate compound dissolved in methanol in presence of acetic acid to remove the triphenyl group. Further, obtained compound 4 reflected in the presence of 20% NaOH in methanol for the hydrolysis purpose and obtained compound 5. Further, compound 6 were treated substituted phenyl bromides in the presence of K2CO3 in ethanol to get desired product. Then, IR spectrum of compound A. In this, here we observe different functional group. The stretching frequency of 3110 shows OH functionality, and then the stretching frequency of 2937 shows OCH3 functionality, and 1782 frequency shows C double bond functionality, and 1634 shows C double bond N functionality, and 1601 stretching frequency shows C double bond C functionality, and 1239 stretching frequency shows C single bond O functionality. And this is the HNMR spectrum of compound 7A. Here proton NMR 1.6022 to 3.16 ppm shows 12 CH2 protons, and 3.55 ppm shows 3 methoxy protons, and 4.98 shows CH protons, and 7 to 8 ppm shows 12 aromatic protons, and 12.24 shows OH protons. And this is the C13 spectrum of 7A compound. And this is the mass LCMS mass spectroscopy, and obtained accurate mass compound 7A is 51111. This is the physiochemical data. In this 7A to 7G compounds, we get 76 to 82% of yield, and the melting point in the range is 194 to 224 degrees centigrade. And we next move to the biological evolution. Here, table 2, antibacterial activity. Here, MIC of synthesized compounds 7A2G on bacterial strains. Synthesized compounds were tested against 4 bacterial strains and obtained the good results. Here, the tables represent the MIC value of 7A to 7G compounds, and the compound 7A, 7B, and 7C shows good zone of inhibition against Bacillus stabilis. This is the anti-TB activity. In anti-TB activity is assessed by Almar blue assay method. The anti-TB result shows the 7A, 7D, and 7G have good sensitivity at 1.6 microgram per ml. Remaining compounds also show sensitivity at 6.2 to 100 microgram per ml. And finally, this is the molecular docking study of synthesized compound 7A2G. Here in docking study shows 7G compounds exhibit least binding energy. Docking minus 10.8 kilocalorie per mole, and with 4 hydrogen bond interaction with 4 amino acids, glycine 22, arginine 47, and arginine 47 and leucine 91. And remaining compounds shows least binding energy compared to standard drug streptomycin. This is the result on discussion. Molecular docking study reveals that compound 7G exhibit least binding energy minus 10.8 kilocalorie per mole as compared to other compounds with 4 hydrogen bonds with glycine, arginine, and leucine. The antibacterial activity results of compounds 7A2G reveals that the compounds 7A, 7B, 7C shows good zone of inhibition against Bacillus stabilis, and 7B, 7C, 7G against Ascaris. Remaining compound shows better minimum inhibition concentration against E. coli and Shigella bacteria. Further, synthesized compounds were screened for antimicrobial mycobacterial studies using microplate Almar blue assay method. And the compounds 7C, 7D, and 7G have good activity with compared to standard drug. Remaining compound shows promising anti-TB activity. Finally, conclusion. We have synthesized a novel series of biphenyl tetrazole derivatives and characterized by using IR, HNMR, C13 NMR, and mass spectroscopy analysis. Further, synthesized compounds were screened for their antibacterial and anti-TB activity. Based on above obtained results, we conclude that synthesized compound 7A to Z are potent for bacterial and mycobacterial agents. These are the references. Thank you, sir. Thank you, ma'am.
Any questions from the participants? So next presentation, Nisha Verma. Nisha Verma.
Any question antandru? Ila next participant Nisha Verma.
Nisha Verma is there. Number 20. Then number 21.
Hi, good morning, madam. I am Ratan Prasad.
Yeah, you can go ahead, please.
Yeah, I'm just sharing. I'll share my presentation. Give me a second. Able to see my screen, ma'am.
Yeah, yes. You can go for slideshow.
Yeah, good morning, ma'am. Yeah, thanks.
If you go for slideshow, then it will be more.
Yeah.
Yes.
Yeah. Good morning, ma'am. I'm Ratan Prasad. We have submitted the abstract for the triazole heterocyclic compounds on chromine molecule. So, in view of biological importance and limited work reported on heterocyclic polysteric triazole compounds on chromine, so we have synthesized various novel 1,2,3 triazole as a heterocyclic bioester of chromine derivatives, and also submitted these molecules and got the biological activity for anti-malarial, antibacterial, and antifungal activities. Abstract, we have submitted for ICC organics. Moving to the next slide. So, keeping this in mind, we have prepared various different analogs, 1,2,3 triazole chemistry conditions under copper catalyzed click chemistry. It's a 1,3-dipolar cyclic that we formed with various analogs of 1,2,3 triazoles on chromine analog substitutes. And initially, we planned the retrosynthesis synthetic analysis by disconnecting the final compound. And the final compound number 1, we have disconnected to form alkyl azides or aryl azides, and followed by the alkyne is intermediate number 3. And alkyne further we have disconnected to form a compound 4, which is a chromine disubstituted 2 disubstituted chromine, which on further disconnection we obtained. We thought we can start with the acetophenone derivative, and which can be again prepared starting from 4-cyano-phenol, so which is commercially available. So with this we wanted to start, and this is a route of synthesis. We have synthesis of various novel 1,2,3 heterocyclic triazole chromine derivatives, starting from hydroxynitrile, benzonitrile. We have done a Fry's rearrangement, O-acylation, and followed by Fry's rearrangement using a Lewis acid catalyzed Fry's rearrangement, aluminum chloride being used here as a Lewis catalyzed for Fry's chemistry. And after further the cyclization and oxa-Michael addition to form chromonone. So chromonone, the double bond keto group functionality was reduced with sodium borohydride, since it is in a benzylic position. So under acid catalyzed thing, we have eliminated to form a double bond in chromine system. Then once after having the chromine, the nitrile functionality was hydrolyzed with a simple sodium hydroxide, a bit higher temperature. And after having a carboxylic acid of chromine derivative, the further chemistry was done with oxalyl chloride using acid chloride, and which was again anacylated with propargylamine. And this is a basic moiety, and we have varied various azide groups here, alkyl azides and aryl azides. And then these two were coupled under copper catalyzed click chemistry, 1,3-cyclopropane, 1,3 dipolar cycloaddition using a sodium ascorbate as a reducing agent for copper 2 to copper 1. That's where it happens. And these were used under catalytic amount. And alkyl azides were used, various different alkyl azides, were used here. And these were prepared using sodium azide with appropriate alkyl halides or aryl halides at in presence of N-dimethyl formamide at about 80 degrees centigrade temperature. And these two were coupled to form various analogs. That's all from my side, ma'am. And I thanks a lot for giving me this opportunity for presenting my abstract for ICC Organics. And thanks to my mentor, Professor Dr. Y.J. Prakash Rao. Thank you. I'll be happy if you have any questions.
Thank you, Ratan Prasad.
Thanks, ma'am.
Any questions from the participants? Any questions from the participants? Ratan Prasad, this you have subjected the nitrile to hydrolysis, isn't it?
Correct, ma'am. Correct.
CN. So how are the yields?
Yields were almost more than 85%, ma'am.
More than 85, you got it.
Yeah.
You didn't try aryl azides, you have tried only benzyl azides, reason?
Aryl azides also tried, madam. And direct
both,
yeah.
Both you tried.
Both aryl azides and alkyl azides, both I tried.
Okay, then, right. Thank you. Thank you once again. So we'll move on to the next one. 22, presentation number 22. Venkatesham Raju. Presentation number 22. Anyone is ready? If 22 is not there.
Sir, good morning, sir. Ready, sir.
Who is that? Who is present?
Venkatesham, sir. Opposite Venkatesham, sir.
Okay. You start sharing the screen.
Okay. Is it? Madam, it is visible?
Yeah, yes, visible, please. You can go for slideshow also. Right.
Good morning to everyone. This is P. Venkatesham from NIT Warangal. I am doing PhD under the guidance of Professor V. Rajesh Gandhi, sir, Department of Chemistry, NIT Warangal. I thank to first ICC 2021 Satavahana University. This is my work, one-part multi-component synthesis of 2,2-oxo, 2-phenyl ethyl, thiode, 10-phenyl, 1,4-10 dihydro 5H indino, 2,1-D, 1,2,4-triazolo, 1,5-A, pyrimidine 5-1, and their character studies. This is my contents, introduction, literature review, and aims and objectives, research work, references. This is my research work. Research work carried on mainly on multi-component reactions. Multi-component reactions are regarded as the convergent chemical process which involves the rapid assembly of polysubstrate systems without isolation of undesirable intermediates due to their atom economy, in which basically most of the atoms contribute to the newly formed bonds. In MCRs, product is assembled according to cascade eliminatory chemical reaction, high selectivity, less waste production. MCRs are powerful tool in medicinal, combinatorial, and green synthetic chemistry. MCRs clearly depends on reaction condition, solvent, temperature, catalyst, the type of starting materials, concentration, functional groups. Use of MCRs is the product formed will be with high % yield and less time, environmentally benign and good substrate scope. These are the literature review. The Laurent and Gerhardt reaction, aldehydes on condensation with ammonia and hydrogen cyanide to form a benzylidene amino, 2-phenyl estronitriles, and aldehydes reaction with hydrogen cyanide in presence of ammonium chloride to form a amino acids is named as Strecker amino acid synthesis. Alpha beta keto esters on reaction with aldehydes and ammonia acetate to form a 1,4-dihydropyridine is named as Hans-thiazole reaction, Hans reaction, Hans-pyridine. And carboxylic acid on reaction with acids, reaction with aldehydes and nitriles to form a acyloxycarboxymides is named as Pasner reaction. It is alpha beta keto esters on reaction with aldehydes, thiourea or urea derivatives to form a pyrimidine derivatives is named as Bignell reaction, and Ugi reaction, it is a four component multi-component reactions to form a acyl carboxylamides. MCMs becomes famous for their atom economic efficiency, employing mild reaction conditions, having high convergence and rates. And when these reactions combined with green solvents, they will justify a central place in the toolbox of sustainable synthetic methodologies. Due to these categories, these reactions are being considered as green synthetic substrates and are widely applied in pharmaceutical industries and late discoveries. As Anastas and Warner's introduced 12 principles of green chemistry, MCRs perform well following at least 7 of them: waste prevention, atom economy, less hazardous synthesis, safe chemical design, binning solvents and auxiliaries, energy efficiency, renewable feedstocks, reduce number of derivatives, and catalysts designed for degradation, real-time analysis, inherently safe chemistry. And this year literature review about triazole molecules. Literature survey has been carried on 1,2,4 triazoles. In the present research work, synthesis of new sulfur and nitrogen heterocyclic molecules were carried out by using multi-component approach. A number of nitrogen sulfur heterocyclic compounds possess good biological activity. These are the following molecules: biologically active molecules: fluconazole, antifungal; letrozole, anti-cancer. This is anti-malarial fused triazole molecule. Literature survey has revealed the mercaptan thione substrate 1,2,4 triazole derivatives exhibits antibacterial, antitubercular, anti-cancer, and antifungal activity. In the present work, the synthesis of substitute 1,2,4 triazole heterocyclic compounds having coumarin, perrol, isoindole, pyrimidine triazole compounds has been undertaken to evaluate their biological activity. The literature review about my present going research work, this imidone on reaction with aldehydes, alpha beta keto esters in presence of ammonium acetate in presence of acid catalyst to form a pyrimidines. The 2-bromo-estophenone on reaction with Indian dione and plus ammonia to form a beta fused pyrrole derivatives. 1,2,4 triazolamine reaction with aldehydes and Indian dione in presence of acid catalyst to form a fused triazolopyrimidone derivatives. The aims and objectives plan to develop substitute 1,2,4 triazoles, synthesis of novel substitute 1,2,4 triazoles heterocyclic compounds using multi-component approach, plan to develop new methods of substitute 1,2,4 triazoles and their biological activity. Among the variety of unfused fused heterocyclic comprising of 5 and 6 member, we have chiefly selected 1,2,4 triazole.
You go to your workplace. It is all introduction only since last floor slides.
Okay, madam. Madam, this is my present work. 1 part synthesis of 2-2-oxo, 2-phenyl ethyl thio, 10-phenyl 4-10 dihydro 5H indino, 2-1-1,2,4 triazolo 5-1,5 pyrimidine 5-1 and their characteristic studies. Design synthesis of fused triazolo pyrimidine derivatives via 1-part multi-component approach in the presence of bridgehead nitrogen atom of these type of heterocyclic compounds showing remarkable applications in the field of biological importance. The target compounds were synthesized by the reaction of 3 Indian dione and reaction with different types of aldehydes to initially form a chalcones, in situ generation of chalcone in reaction with in this condensation with 5-amino 1,2,4 triazole thiol in presence of DMF K2CO3 to form and base to form a triazolopyrimidones. After consuming these reactants, we added different types of phenyl bromides to form a thioalkylated products with good percentage of yield. To obtain all the final compounds were characterized by their spectral studies NMR mass 13C IR. This is maximum. Then this methoxy 3 singlet protons is appears from 3.85 delta ppm, indicates 3 methoxy protons. Due to anisotropic effect of sulfur, these two adjacent to CH2 protons is different in an environment and appears as a multiplet from 4.60 to 4.73 delta ppm. The quaternary carbon CH, one singlet carbon, is appears at 6.46 delta ppm. Remaining hydrogens from 7.57 to 8.61 delta ppm indicates aromatic protons, and the NH, one singlet proton, is appears at 12.65 delta ppm. The mass spectrum of this final compound, exact mass of this compound 526.118 and 526.115 is appears. This references. The conclusion: we have synthesized final compounds in scheme 1 by using MCR approach. The present method has advantages. MCRs are highly convergent in nature, reduce large number of amounts, wastage, shortening of the overall number of steps, and simple workup procedure. No application of column chromatography for sincere compounds. Final compounds are purified by recrystallization method. I acknowledge my thank to my Professor V. Rajeshwar, sir, Research Supervisor, Department of Chemistry, NIT Warangal. I thank to Indian Council of Chemists, Satavahana University, and also thanks to Usmania University. I thanks to Director NIT Warangal. I am thankful to CSR New Delhi for providing financial assistance. I am thankful to all the faculty members and my co-research girls. Thank you, ma'am.
Thank you, Venkatesham. We'll go for the next one. Namrata, you want to present?
Yes, madam, I'm ready, madam.
Ready, then start sharing.
Okay. Madam, is it visible, madam, my PPT? Madam, sir, is it visible?
Yes, madam, it is visible.
Thank you, madam. Thank you.
Visible. Your time is 8 minutes, madam.
Okay, madam. Okay, okay. So I'm Dr. Namrata, Head Department of Chemistry, University College of Science, Satavahana University. I want to give some importance on the natural products, as I did my PhD on natural products. So what are natural products actually means? Natural products, these are the chemical constituents isolated from the natural sources, which may be plants, marine flora, fauna, bacteria, soil, and microorganisms. And these natural products, once they served as only source of medicines to mankind. And over 3/4 of the world population relies mainly on plants and plant extracts for healthcare. And the structure determination and biological activity screening of natural products having history of medicinal use by taking clues from Ayurveda, Siddha and tribal medicine is an important activity of medicinal chemistry. A number of phytoconstituents has been isolated from plants, which include cellulose, glycosides, saponins, alkaloids, terpenoids, and flavonoids. And chemical structures which are directly isolated from plants, which are biologically active, can be termed as lead molecule. In most of the cases, few natural products are directly used as drugs, but in most of the cases, the chemical modification of the lead structure gives more potent synthetic or semi-synthetic analogs. We can quote an example, vincristine and vinblastin, which are the alkaloids extracted from Vinca rosea flower. They are anti-cancer agents, but these are the only directly used natural product extracts which are used to cure the cancer. And some other like quinine, which is extracted from Cinchona saxaroba plant, it can be used as an extract. Semi-synthetic analogs, which include neploquin, pamaquin, they are better potent anti-malarial agents. Synthesis and screening of a structure similar to natural product lead is an important technique in drug discovery programs. In India, about 20% of the drugs sold are plant derived, and useful to treat chronic diseases of liver, kidney, and skin. And people prefer Ayurvedic medicines as they are cheaper and with no side effects, and equivalent medicines in allopathies is not available. And also several indigenous programs are being carried out through all over the world, and also particularly in India, to discover plant-based drugs in view of diverse vegetation here. Several natural products drugs isolated from plants used in traditional medicine have potent anti-plasmodial action in vitro and represent potential sources of anti-malarial agents. Also, good number of plant-derived compounds are gaining importance in clinical research, mainly in anti-cancer and anti-malarial therapies. Also, the clinical applications of artemisinin, taxol, and camptothecin, which are the examples of natural products drugs that are undergoing clinical trials and commercial development. And also, it is estimated that about 60% of anti-tumor and anti-infectious drugs already available in the market or under critical trial. They are of natural origin, and majority of these molecules are not able to synthesize because of their economic deficiencies, and therefore they depend mainly on the plants as the only source. And India's use of plants dates back almost 5,000 years, and also although traditional medicine is widespread throughout the world, its practice is handed over from generations to generations over thousands of years, and oldest of that an Ayurvedic is the Charaka Samhita. And about 8,000 herbal remedies have been codified in Ayurveda, which are still in use in many dispensaries. For a long time, the only way to use plant medicine was either direct application or use of the extracts, plant extracts. And finally, I want to say is, as my guide used to say that whatever the present known drugs which have been working today for the major challenges, so the behind active principle for the discovery, drug discovery, is only the lead molecules, because almost every plant is a source of a medicine. Every plant which really codifies in Ayurveda, that is Ayurvedic text, that is Charaka Samhita. So, and though still there is considerable development in medicinal field, still there remains an urgent need to develop new clinical drugs which result from malfunction of central nervous system like Alzheimer's, Parkinson's disease, schizophrenia, sleeping disorders. Till now, it is only under progress, but we have not succeeded in developing the nervous system active drugs. So flavonoids, which are the natural products isolated from plants, were known to possess wide range of biological activities like central nervous system activity, cardiotonic activity, hepatoprotective activity, anti-inflammatory activity, and lipid lowering activity, and anti-neoplastic, that is anti-cancer activity. And these flavonoids really they are found to be a rich source of compounds, chemical constituents for treating almost most of the health disorders. Flavonoids, I can quote one example. Flavonoids isolated from plants, central nervous system activity, for example, 6-bromoflavone and 6-bromo-3-nitroflavones were known to display fumazenil binding to membranes from rat cerebellum, indicating selectivity of benzyl omega receptor type. And they also possess anxiolytic properties.
Madam, please conclude.
Or superior to diazepam. Okay, sir. No. Thank you for your patience hearing and for giving this opportunity to Ashok sir and Leela madam. Thank you.
Namrata. Thank you, Namrata. It's time for the invited lecture, the last invited lecture by Dr. Raj Reddy from ICC.
Okay.
So
ma'am.
after the lecture, we'll go for the remaining oral presentations, but with the time restriction only 8 minutes because
Okay, madam.
we have
Thank you,
to
madam.
wind up by 1:30 or 1:40. Sir,
Thank you. Madam. We
Right,
are,
thank you.
we are joining.
Sir, join a minute. Ainda, sir. Sir, Mari. Sir, Raj Reddy, sir. Sir, good morning, sir.
Yeah, madam, good morning. Good morning, sir.
Sir, screen sharing. So I request Professor Ashok sir to introduce the speaker, Dr. Raj Reddy.
This is Professor D. Ashok, Department of Chemistry, Osmania University. It gives me an immense pleasure to introduce Dr. Chada Raj Reddy. He has obtained BSc from Kakti University, MSc from Osmania University. After completion of PhD at CSIR, Indian Institute of Chemical Technology, he moved as postdoctoral fellow to University of South Florida, Tampa, USA, and subsequently to University of Mississippi, USA. He returned to India in 2005 and joined as principal scientist in Sai Life Sciences, Hyderabad. After 1 year, he joined the CSIR IICT Hyderabad as a scientist at the Department of Organic Synthesis and Process Chemistry. Presently, he is working as senior principal scientist. His research interests are both fundamental and applied research, include the chemistry of propargylic alcohols towards synthesis of heterocycles and carbocycles, enine assisted reactions towards synthesis of polyaromatic hydrocarbons, and bioactive natural alkalides. Process development of APIs such as process for favipiravir, remdesivir, S, pregabalin, key fragment of erbilin, mesylate, and TLR 7/8 agonist molecule used as an adjuvant in Covaxin vaccine for COVID-19 have been developed and transferred to various organizations. He received many awards from various research and academic institutions. He is a recipient of CSIR Technology Award 2021, Nasi Reliance Industries Platinum Jubilee Award 2020, CSIR Technology Award 2020, CRSI Bronze Medal 2018, CDRI Drug Research Excellence Award 2017, Dr. A.K. Singh Memorial Young Scientist Award 2014, Aura Young Scientist Award 2011, and AP Academy Young Scientist Award 2007. He is a Fellow of Telangana Academy of Sciences. He is an author of 142 publications, 10 patents, 3 review articles, and 2 book chapters. Under his supervision, 22 students have been awarded PhD degree. Presently, 12 research fellows are working for their PhD. Above all, he was my own student. I am very proud of Dr. Chada Raj Reddy. Raj Reddy garu, please.
Thank you, sir. Are you able to
present your presentation?
Yeah. Are you able to see the slides, sir?
Yes, yes.
Okay. Thank you. Thank you. Very good morning to all. First of all, let me thank the organizers for giving me this opportunity. Indian Council of Chemists and Satavahana University, Karimnagar, for organizing this annual conference. Before begin the presentation, I would like to thank Professor Ashok sir for his kind words of introduction. It's always a great honor, sir. You are the one alphabets of organic chemistry you taught me, and now and again you are introducing me, and I am happy to share some of my research accomplishments in this prestigious conference. So today I am going to speak some of our recent accomplishments using this propargylic alcohols and propyolamides as handy synthons for the synthesis of various heterocycles. So both these propargylic alcohols and propyolamides, from the nomenclature, you can figure it out. It has alkyne functionality. So what I'm going to do today is how this alkyne functionality plays a key role in various cyclization reactions so that we can build our heterocycles the way we want, having the appropriate substitutions. So before going to the actual topic, just I would like to share what are the research activities in our lab we are doing at CSIR IICT. So our focus of research mainly, as it is a mission of our institute, that we do collaborate mostly industrial collaborative research, where we develop a process for high value APIs or drugs. And of course, we also make new chemical entities for our drug discovery program at various organizations. So by doing this, we also actively involved in development of new chemistry, wherein either it may be methodologies or total synthesis of bioactive natural products. Both these will give a good training to the PhD students, and also we can develop novel methods for the new chemical entities. So as I mentioned in my title slide, these are the two variety of propargylic alcohols we are focusedly working from the last 15 years. And recently, 4 years ago, we have started the chemistry of these propyolamides. And in the coming few slides, I would like to share these recent results from these substrates. So before just entering to the actual subject, I am always, happy to share that CSIR IICT is contributing to the society, and particularly in the last 2 years when pandemic began in 2020 March. But we at our lab, we work 24/7 to contribute to this pandemic situation. And in the beginning, there was no treatment. All of you know that. And initially, in the month of February itself, WHO announced some of the list of compounds which may work towards this COVID-19 treatment. So we picked some of the molecules, and within 3 weeks of period, we developed a novel process, this particular favipiravir, because even if it approves, there was no process in India for this molecule, because it was only used in Japan for like the way we use cetirizine. They use this favipiravir in Japan for normal allergies. So initially, many scientists and WHO also anticipated that favipiravir may work for this COVID-19. So I'm happy to share here that within 3 weeks, we completed the new process with the available chemicals, because March 23rd completely locked down, and even we cannot go out, but we stayed in our guest house in the institute with a few students, and worked a 3-shift system. And on 15th April, we transferred this process to Cipla so that they could launch this tablet in the market on 24th July. You can see that it was developed with IICT. So IICT logo is printed on the marketed price. So we are happy to see this. And another major contribution our laboratory gave during this COVID period, after the project of this favipiravir, sometime in July, Bharat Biotech approached that they are using one molecule, small molecule, as an adjuvant in their vaccine. So that at that time it was only under trials, but they know that suppose if it is market, it approves, then they required in large quantities. So they need a viable process which can viable to make in kilogram scale. Because when they licensed this particular molecule, it was only milligram scale synthesis and required a lot of purification steps, very low yielding steps. You can see here its overall yield is only 0.7%. And then we developed within 4 months of period, again, a new process now which is scalable to up to kilogram scale, and we reduced 1/10 of the cost, and the overall yield is 10%. So you can see the 15 times improvement. And the important achievement is there is no chromatographic purification. So this again, we filed a patent and then we demonstrated to various companies, and with the license they are making and supplying to Bharat Biotech. So this is one of the another contribution from our laboratory, and it was approved in January 2021. So that time onwards, I think lakhs of doses have been administered to various persons in the country as well as in other countries. So I can proudly say that whoever took the Covaxin 2 doses, they have 30 micrograms of this compound. The technology made at ICT is there in all of your body. So it always, to see that proud that we could contribute to the nation through our science. So these are the two major contributions in the last 2 years. Now coming back to our basic research, apart from the natural product synthesis, we also work on methodologies, as I mentioned. So one of these, our important project since last almost 15 years, I was involved in this use of propargylic alcohols in organic synthesis. So why these propargylic alcohols are important? Because it has a multiple handles. You can see that it has a hydroxy group. It can act as a nucleophile. If you eliminate this hydroxy, it becomes alene. That is again intermediate for various reactions. And as such, alkyne acts as an electrophile so that you can add various nucleophiles onto this alkyne. If you remove hydroxy group in the presence of acid catalyst, it generates the carbocation, and that again can react with various nucleophiles to generate carbon-carbon or carbon heteroatom bond formations. So now, once you have these particular reactions, now using this alkyne as a handle, you can do ring expansion reactions or various reactions. You can see this is what our main focus, where we use this as a handle for nucleophilic substitution via carbocation generation, and then we used this alkyne as a handle for cyclization reactions. So using this concept, in the last 15 years almost, we have generated a variety of heterocyclic synthesis methodologies using this propargylic alcohol. Here I have shown only representative ones, but you can see that starting from 2008 onwards, so we are continuously working on this particular substrate to generate a novel heterocyclic systems. So today, from this particular topic, I would like to share a couple of recent results where we have synthesized this hydroxycarbazoles. Because why this hydroxycarbazole is important, you can see from here, from this picture, that several natural products are having hydroxy group at this particular third position of this carbazole in various natural products, and which most of them are biologically active compounds. So if you have a new method for synthesis of these natural products in large quantities, it is always highly useful. So what is the importance of our method? There are several methods available for this hydroxycarbazole synthesis. However, to make this hydroxycarbazole, always you need to have a pre-installed OMe group or O-alkyl group on your carbazole. Then you de-alkylate to get this hydroxy group. That is one of the approach. The other approach is you take a carbonyl group as a handle, then do the reaction so that that will undergo enolization to get your hydroxy group. But now what we have done here, we have developed an intermolecular reaction using propargylic alcohol, where the hydroxy group is coming from external source as a water. So this method is for the first time, it is unprecedented, and you can see here that uninterrupted propargylation followed by hydroxylative benzanylation. These two are the key reactions during this process. So both the reactions we could accomplish in one part, and the first propargylation reaction is in the presence of triplic acid, and the second annulation requires both palladium as well as triplic acid catalyst. So we have demonstrated this method on 27 different substrates having various substitution, which I will show in coming slides. So initially, having the optimal condition, you can figure it out from the publication. So we move to explore the scope of this propargylic alcohol. So propargylic alcohol on this particular aromatic ring, we studied various groups, whether electron donating or electron withdrawing groups like nitrocyano, even a biaryl ring naphthyl group also comfortably participated in both the propargylation followed by benzanylation reactions. Even the terminal alkyne group also successfully provided this corresponding hydroxycarbozones. Now having this success, here I have shown only, you can figure it out all the examples in publication. And we also shown the effect of this R2 group. You can see whether it is aryl or electron donating aryl or even alkyl group also participates successfully to give this product. And however, this particular substrate, you have very electron rich aryl group here, trimethoxy group on the benzene ring, and we have actually anticipated this product by hydroxylative benzanylation reactions. But instead of this, we got the product where the alkyne did not participate in the reaction. Instead, this trimethoxy aryl group, because it is so nucleophilic in nature, before the alkyne reacts, this aryl ring reacts with the aldehyde and underwent dehydration to give this. This is the only exception in the substrate reactivity during our scope of the propargylic alcohol study. So further, we also explored the scope of various carbonyl indoles, particularly studying various ketones, because in the previous slide you can see all are indole carboxylic aldehydes, whereas here you can see that the indole ketones, either aryl ketone or having again electron donating or withdrawing group, and heteroaryl group, even alkyl, simple alkyl ketones also like cyclopentyl or cyclopropyl ketones again underwent into this cascade reaction, propargylation followed by hydroxylative benzanylation to deliver the desired products. So later what we thought, if you extend another alkyne functionality, whether it will be able to create a handle for another cyclization reaction. So if you see that as per the first reaction, this is the product we will get in the reaction, and we have now extra handle of this alkyne, and we are getting this hydroxylation at this position. So now if you further treat whether this hydroxy again undergo cyclization with this alkyne to give this another furan ring, so that two annulation reactions in the same part. So this was our idea, and we prepared this particular diacetylenic alcohol and treated with the optimal conditions, and we are delighted to get this diannulated product wherein two carbon-carbon bond formation happened and also two carbon-oxygen bond formation within a one-part reaction. So this again extended to another substrate to just see whether the scope of reaction is only restricted to this substrate or other substrate also it works. So another substrate where we are having this naphthyl and alkyl ring, alkyl substitutions, we explored and we successfully got this diannulated product. Now having the scope of reaction, just we wanted to propose the mechanism. For that, we need to do some control experiments. What is the role of triplic acid and where this hydroxy group is coming. So to prove this, we used OY18 labeled water in the reaction. So we got the OY18 labeled hydroxy carbazole as a product. Along with, of course, we have some moisture. So we also got the without labeled product also. But overall, we could confirm that the oxygen, this hydroxy group is coming from the water. And another control reaction, if you don't add triplic acid in the reaction, there is no cyclization. So that means triplic acid is playing a key role not only in the propagation of first step, but also in the second step it is playing a key role. So based on these control experiments, we proposed that this is of course a straightforward. When you treat it with any acid, it will generate the carbocation. This indole third position is very much nucleophilic in nature, so it gives the CC bond formation. So from here, now the palladium plays a key role. So when the triplic acid activates the alkyne, the palladium triplic acid combination gives the palladium triplet, and this will give vinyl palladium complex to leads to this generation of this allene. Again, this allene in the presence of addition of having hydroxy group from water as a nucleophile, it adds onto this particular carbonate allene. Now it generates this enol to de-aromatize, again back to re-aromatization of this indole ring as a benzanylation, cyclization followed by dehydration to give the hydroxy. So from this, so far we have seen that how you can generate the hydroxycarbazole using propargylic alcohols and further extension of furanylation. So having that results later, what we thought, we wanted to further study based on these dicyclization reactions. In previous work, we have studied only two substrates where the hydroxy is generated, which again used for cyclization. But here what we thought, whether can we make a benzofurans or indoles, particularly fused to another heterocyclic ring or another aromatic ring. You can see that this kind of fused benzofurans or fused indoles are a key structural component of eastfolin D is the alkaloid. Again, dichiodendrin is another natural product alkaloid. Otherwise, also they are very much useful in various dyes and electroluminant properties having this aryl or heteroaryl fused benzofurans and indoles. So if you see the literature, the general synthesis of these methods relies on the two type of concepts. Either you take a heterocycle ring, maybe furan or pyrrole, and you construct the benzene ring so that you will get this fused pyrrole or fused furan, benzofuran. Other way, you take your phenol or aniline and build your furan ring or pyrrole ring so that you will get this fused benzofuran or indole ring. These are the only methods available till now in the literature. But what our interest is, having this diacetylenic alcohol in our hand, we thought whether it will go to domino fashion, furanylation or pyrrolylation followed by benzanylation, so that both the rings we can build at one step, which is completely new and unprecedented. So keeping this in mind, we planned our reaction initially taking this basic dienol, which we have prepared simply from benzaldehyde and this dialkyne, and we have taken a 1,3-dicarbonyl compound ethyl acetoacetate so that we can make in one part both the furan ring and benzene ring. So if the fused benzofuran we can reform. So the first reaction is a propagylation. This is active methylene, so it's a carbon-carbon bond formation. Then it undergoes cyclization in the presence of base to give the furan. Now it has one more handle, alkyne, for further benzanylation in the same way. Also undergoes benzanylation to give the expected product. So these are the usual optimization. As usual, the first step works with any Lewis acid comfortably. Only thing we need to optimize since a one-part reaction, the combination of acid base, which is giving better yield. So finally, we concluded that the boron catalyst, BF3 dihydrate and potassium carbonate are the best combination to get this fused benzofuran in more than 90% yield from these dienols. So this was again, as usual, we extended to various propargylic alcohols, dienols, acetate, and we also varied the dicarbonyl compounds. You can see here that not only esters, it also successful diketones, as well as you can see that here from it is also successful from the
ప్రాబ్లమ్ ఏనా లేకపోతే ఇంటర్నల్
cyclic diketones. Having this success on various substrates, we wanted to synthesize the natural product analogs, as I have shown in my first slide.
ఇక్కడ లాజ్ తీసుకుపోవాలన్నట్టు 2 days.
Histopholin D is one of the alkaloid having this indole fused benzofuran. So we have to start the reaction from indole based to dienol, treat with your various diketo substrates, maybe ethyl acetoacetate or 1,3-dicarbonyl. So the corresponding benzo-fused compounds demonstrated that this method is useful to make histopholin D analogs. Now, having this success, we further by adding amine into the reaction instead of furan, can we make a pyrrole? And again, whether that will undergo the further cyclization, so that now this was our basic idea. So that here we can really demonstrate 2 carbon-carbon bond formations as well as 2 carbon-nitrogen bond formations in one part reaction. So when we started our reaction, actually we had difficulty in synthesizing this pyrrole because this acid aniline is a base. So in the presence of BF33, aniline is the problem. But however, we further optimized instead of room temperature, if you increase the temperature up to reflux in toluene, the reactivity finally the pyrrole formation comfortably. And second step also, instead of potassium carbonate, we have to use DBU to make again followed by cyclization. So finally, we optimized conditions for this particular benzo-fused indoles, and we extended our work for to show the generality on variety of substrates by taking either various dicarbonyl compounds. Even we took different amines instead of aniline, benzylamine, and other few amines also studied. Here I have shown examples. And this particular, you can see that it is a dendrin, as I mentioned, a natural product having this particular scaffold, indolo fused indole. So that can be made from this method. We have shown as application of this method for the synthesis of dictyodendrin scaffold. So this is all about a propargylic alcohol generated from a aldehyde. So far we have seen. Now I am little bit switching the topic. This is again, it is a propargylic alcohol, but derived from a different source. Now you see here how many functionalities are there. All of you know that Bailey-Silman adduct, Morita-Bailey-Silman reaction, it is generally aromatic or heteroaromatic or aliphatic aldehydes. Treatment with a acrylate, you will get this functionality. So Bailey-Silman adduct is a multifunctional synthon that has an alcohol group, that has a olefin, which has a ester, can be converted all these functionalities into variety of further reactions. But what we did when we are doing work on our propargylic alcohols, we thought whether can we make a Bailey-Silman adduct from this propyl aldehyde, so that we are introducing another group here, alkyne. So now it became a multi-functionalized synthon. So maybe various annulation reactions are known. So you can see that when we have this idea sometime in 2010, we obviously we verified the literature, what is available in the literature, whether somebody has made these substrates or not. To our surprise, this substrate has not been made, although there are 4,000 literature references, including many of you know, I think from India, Professor Basavaya is a like kind of a father of Bailey-Silman reaction, worked on throughout his career on Bailey-Silman reaction. So, but despite of 4,000 references are known in the literature, we did not find a single reference for this propyl aldehyde derived Bailey-Silman adduct. So that gave us some motivation, whether is it really problematic to make or it's only accident that nobody has made. So what we thought, it was really a tough time and one student, Dr. Damodar Reddy, presently is in US, who struggled for more than 1 year to optimize this particular condition, because this is getting polymerized when we are using DMSO and DAPCO or other reagents for this Bailey-Silman reaction. But finally, after struggling for an year in 2011, finally he established the proper conditions to make this Bailey-Silman adduct from alkyne like propylaldehyde. So now this became a new propargylic alcohol system for our research program from 2011, and since then we have converted these alcohol into variety of derivatives, acetate, because this will give handle. I will show you in coming slides, and later we carbonate also. But today what I am going to show you is the important reaction. Although we made this alcohol in the last 10 years, we could not use this alcohol directly for the conversion of heterocyclic synthesis. But very recently, our efforts are successful to use directly this alcohol into our reaction. So today, this is what I am focusing. But before that, I will show one slide how we have used this alcohol by converting to this acetyl derivative or carbonate derivative to synthesize various heterocycles. So as I mentioned, our first paper we published in 2011, simply a pyrrole synthesis. See, if you have this alcohol convert to acetate, now you add any amine nucleophile. First, it will go allylic substitution to give this derivative. Now, having another nucleophilic source, it undergoes to cyclization. Aromatization is the driving force. You can make the pyrrole. Further, we extended to thiophene, furan, even oxidative annulation, so that acyl furan. So variety of reactions, you can see more than 20 projects we have completed by using this single substrate. Still further, we are working to identify the new dimensions of these propargylic alcohols generated from propylaldehydes. So today I am going to cover one particular topic where for the first time we have used propargylic alcohol as such without converting to acetate or carbonate in our annulation reactions. So you can see again, whenever we were developing a methodology, there is always a background where that particular heterocycle is important, whether it is there in a part of natural product, whether it is there in a part of a drug or part of a pharmaceutical molecule. So when we took this target as a pyrrone ring, so you can see that it is present in various monoterpenoids and diterpenoid molecules. This particularly, you can see that these aryl pyrones are very much important. So our literature search revealed, if you want to make this particular pyrrone ring, one option to take this alkyne, you need to have here cis geometry of this olefin, and now this hydroxy group undergoes cyclization, particularly electrophilic cyclization. So you are adding one electrophile here. Other way of doing is you can have this 1,3-dicarbonyl nature, and then you go cyclization, you will get here in a hydroxy group. So from these two literature approaches, you can see that either it is a monofunctionalization here, or there is no functionalization at all, only cyclization. But what we planned from our Bailey-Silman alcohol, this particular propargylic alcohol, to make this functionalized true pyrones, it is giving difunctionalization. If you plan from ICL treatment, you will get your iodo here, the chlorine is here, because now here you have two handles. So this is the first difunctionalized cyclization towards this two pyrones method we have developed very recently. We have published this, and we have showed the generality of this reaction on 48 different substrates, and further we have converted having this chloro functionality to variety of further substrates. So it is providing a handle for further diversification. So coming to the reaction, as usual, we are of course master of making from the last 10 years this alcohol. So when we treated with iodine monochloride, it undergoes the electrophilic substitution. Of course, I'm not showing here the optimization table due to lack of time, but you can figure it out from the publication. So here it is giving this iodo functionality on the alkyne, and chlorine functionality from this particular place after the cyclization. So these are the variety of Belli-Silman alcohols generated from different propylaldehydes. We have shown here even the propylaldehyde derived from estrone is also comfortably converted to the corresponding iodopyrone. So then further we extended not only iodine electrophile, we also extended to selenyl as well as sulfonyl. So for this purpose, we used diphenyl diselenide or diphenyl diselenide in the combination of copper chloride, so which generates the phenyl selenide electrophile, which coordinate with the alkyne for further cyclization reaction. So this was also very comfortable. I'm not going into the details. You take any substrate, whether it is electron donating or withdrawing substance or halo group or any other group. So comfortably both selenyl annulation and sulfonyl annulation were successful. Even if you have a alkyl group here or any other bulky group, a natural product also can be comfortably derivatized for this particular seleno and or sulfonyl annulation reactions. So as I mentioned, I think having this chloro group, what is the further we can derivatize this? So first we demonstrated whether the reaction is scalable or not. So we could scale up to 10 gram scale, 11.5 gram compound. We could comfortably prepare from 8 grams of the starting material, because we are adding selenyl and chloro heavy groups onto this. So 83% overall yield. Having this in multiple gram quantities, the chloro functionality can be further. You see that whether it works under Friedel-Crafts alkylation reaction, or you can do base catalyzed alkylation reactions, or further treatment of this phthalimide group. The chloro also can be converted to azide. All of you know the azide can be further quick reaction to make variety of triazoles. Even very importantly, we converted this chloride to triphosphonium salt, Wittig salt, and in the presence of base, it generates a stable halide. Treat with any aldehyde so that you can couple to any other aldehyde functional molecules. So this dihydropyran moiety can be attached towards the modification of bioactivity. Further, having this iodo group here, you can do with annulation, so that benzoannular derivative you will get, and further we can oxidize. Of course, this is a small reaction we performed. Now, finally, for any method we develop, we wanted to propose a mechanism, because how it works. So now here, looking at this, you are adding a nucleophile. You are also adding, this is a nucleophilic, this is electrophile you are adding. So now the question is whether chloro is adding first, or whether your iodo or selenium group is coming first. To verify that, what we have done, we converted our compound to chloro. We could not make it, so we made it to bromo. Then we further treated with ICL or diphenyl seride. We observed that no reaction. We recovered the starting material as such. That means before adding the chloro or your other group only, here the cyclization is happening. After that only the nucleophile is happening. With this control experiment, we can confirm that. So now we can propose the mechanism comfortably. So your iodonium electrophile will give this iodonium ion. Now it undergoes the cyclization of this carbonyl group of ester group. And now this chloronucleophile is there within the reaction, which undergoes this allylic substitution reaction to release this molecule. Finally, hydrolysis provides your iodopyrone. Similarly, same with diphenyl diselenide or diphenyl sulfide in the presence of copper, which generates this sulfenium or selenium halide, or that again opened with a similar way. Instead of iodine, you can use the selenium pH as the group here. So the same mechanism works for both the transformations. So from here, the last topic in next 5 minutes, I will be covering this reaction. Again, it is a propylamide reaction, dearomatization. This is another project we are currently working. So far you have seen mostly aromatization or extended conjugation is the driving force for the reactions. Now here we are going against the aromatization part. So that is called dearomatization. So because why dearomatization is important, you can see from these natural products, We have variety of the cyclohexane diones or azaz pyrocyclohexane diones. The convenient method for preparation of these compounds are your dearomatization reactions. So this project we have started 4 years ago, and when we want to have a project, so we search the literature completely thoroughly, what is known, what is new, we can do. So we made a review in 2017 and planned our projects in such a way that we can contribute to this field. So far in this field, this is the most used substrate. You need to have this OMe group for the dearomatization of this reaction. So we can do either electrophilic cyclization. This is basically called ipsocyclization. When the carbon cyclization happens at the same position, it's called ipsocyclization. Here, dearomatization is the process happening. And also you can do the radical reactions with various radicals, either carbon, sulfur, or nitrogen. Any radical also you can add on the triple bond, and it undergoes ipsocyclization. So these are the two ways of dearomatization reactions and ipsocyclization you can do to make your pyrocyclohexadiones. So having the literature background, what we found is that this acylation initiated cyclization is one of the important reaction. And when we search into the literature, only two methods are known. Either you use aldehyde or benzoyl chloride. So there is no generality, because you mostly aryl chlorides used or used only aldehydes. But here we wanted to see whether we can introduce simple alkyl group or acyl group via decarboxylative radical generation. So after optimization the conditions, silver catalyst gave the best result in the presence of acid to generate this acyl radical. So it is a decarboxylative acylation followed by ipsocyclization, so which were studied on various substrates. So this is how it happens. I'm not going into the full details. So the acyl radical generation, addition followed by ipsocyclization to give after the hydrolysis the required product. So this was again, as usual, we demonstrated on various N-aryl propyolamides. You can see aryl or heteroaryl, or you can see here that if you have alkyl group, the reaction did not work because stability of the radical. And even on the N-aryl group also we could show some substitutions, and then further various N substitutions also were demonstrated. Even scope of keto acid, not only pyruvic acid, we can have other isoprobutyric acid, or you can do aryl ketone also can be introduced, a long chain ketone also can be introduced. Further, we extended this work very interestingly to tricyclic scaffold, starting from the bicyclic propylamide, and you can do, this is a very unique scaffold present in various natural products. So we demonstrated more than 10 examples. So for the spiruloquinolone derivatives. So having acylated example, we wanted to extend this method to whether alkyl radical also can be generated under the same conditions from carboxylic acid. Yes, we can do that. So we used various aliphatic carboxylic acids, phenylacetic acid, or cyclic carboxylic acids. You can see here from adamantane and other substituted carboxylic acids can give the corresponding alkyl radical for the cyclization reaction. Even we can use this diketone also. We can generate the radical here, active methylene group, which undergoes cyclization reactions. So very recent one of the publication, you can see from our group, having so far we have seen in the previous slide this azaz pyrocyclohexane diones, but we do have various natural products, this kind of cyclohexane diones, bicyclic cyclohexane. This is completely carbocyclic, there is no heteroatom in between. So the way for this is we designed this way so that we have arylated enone, biaryl enone, so that we can, if you have a methoxy group, it will give this spirocyclic nature. If you don't have a methoxy or other group, you simply go to orthoannulation. So this is also very dibenzocycloheptanone is also important scaffold in various natural products. So here we have developed a new upcoming area. This is electrochemistry, where you no need to use any chemical oxidant in the reaction. You can see our previous reaction, we have used potassium persulfate and other oxidants. So that can be avoided from this reaction. We no need to use metal also. So either it can go orthocyclization or ipsoannulation to give this pyro. Since the today topic is pyro, I'm not going to orthocyclization examples, but you can see that these are the substrates we have shown for this particular method, that it could work with various selenylated cyclohexadienones, biarylated cyclohexadienones. And for this, again, as usual, we did some control experiments to prove that the mechanism is a radical mechanism. So when you add radical trapping reagents, the reaction did not work. Or even without diphenyl cyclization could not happen. So this gave confidence to propose this mechanism, which is of course there in the publication. So now to come before conclusion, so far the ipsocyclization is either propiolamides only it is known. So far it is not known in any other substrates. But when you look into the literature, what we found, we want to extend this concept to various other chemical scaffolds. So you can see the sulfonamide, particularly the sultam, having the sulfur dioxide and aza nitrogen group. Various drugs are there in the market. Even you can see saccharin, camphor sultam. All these things are having this cyclic sulfonamide functionality. And particularly you can see here, this is a aldoreductase inhibitor having spirocyclic nature with sulfonamide. So whether can we extend to this pyrocyclization, ipsocyclization, instead of a simple carboxamide, can we do with sulfonamide? So this actually preparation of this alkyl sulfonamide itself, there is only one paper long back, so there is no proper method available to make this. So now we developed a method for the synthesis of this alkynyl sulfonamide, and the reactions are presently, we are optimizing the conditions, but I could share here happily that various these radicals and electrophiles we could introduce at this position for cyclization. So the project is presently underway. So sometime in the future, when I get opportunity, I do believe that I could share these important results in near future. So with this, I stop here. So before stopping my lecture, I must thank all the key players. They are the players in the ground, but only I am just representing them to share our results. But they are the worked at the bench day and night to make our ideas into reality. So far these are the students participated. Of course, many of them made the base for our projects. But presently today, mostly I have presented the Subbarao and Amul Patil work, and they are going to write thesis sometime this year, coming year. So of course, this requires support from the institute head always. In the last 15 years, I had a good support from all the directors. So these are the two industries in the last couple of years. They supported our projects for vaccine as well as the favipiravir. Of course, we always do have a constant funding support from our parent organization, CSIR, and we also do have various projects on Department of Science and Technology, Ministry of Earth Sciences. Of course, SERP is another funding agency supporting a lot to our project. So with this, once again, I would like to thank the ICC Indian Council of Chemists and Satavahana University for inviting me to be part of this conference, in particularly Professor Ashok sir and Lilavati madam for inviting me. Thank you, Vananda.
Thank you, sir, for your informative lecture on this. Any questions from the participants, please? Participants, anyone wants to interact with the speaker? No? Yeah, if no questions from the participants, sir, we would like to thank Dr. Rajareddy sir for readily accepting our invitation in delivering the lecture on cascade reactions of propagylic alcohols and propiolamides. Sir, we are extremely grateful to you for sparing your precious time in sharing the knowledge with our participants. Sir, your lecture is very informative. I think it is truly inspirational for our participants. They can pick up some of the work from your slides also. So, sir, you are explained very clearly or developed recent methodologies like use of these propagylate alcohols from different sources like aldehydes and Bailey-Silman monadics and conversion of them to different heterocycles. Sir explained very clearly and especially focused like I could grasp it from sir lecture, what is that is different methodologies in developing two cyclic rings simultaneously, that is in the synthesis of benzofuran derivatives and later their development to the further to the natural products, etc. And in the synthesis of difunctional pyrones, then propiolamides to dearomatized heterocycles, etc. So very interesting. So once again, we thank you, sir, for your inspirational lecture. So thank you, sir.
Thank you, Rajreddy garu. Thank you.
Sir, unable to hear you, sir.
Thank you very much, Rajreddy garu.
Thank you, sir. Thank you.
Your lecture is very nice, excellent, and very informative and useful. And I am very much confident that our all participants have enjoyed a lot about your lecture. Thank you very much for sparing your valuable time.
Thank you.
I am very proud of you.
Thank you, sir. Thank you.
Alex. టైం ఎక్కువ లేదు కదా సార్ 2 o'clock అంటే హార్డ్లీ 1.5 hours ఉంది మీకు 1.5 hours. We'll continue with the oral presentations. Not much time is there, so we request the participants to restrict it to 8 minutes. So the next presentation is 23 by Ram Kumar and Rajalakshmi. Are they ready? Next one is 23, if not 24. Munnaram and Ruby Singh.
Yes.
Who is
Hello.
ready now? Who is ready?
Munnaram Seni, ma'am.
Yeah, start. Please start sharing your presentation and then start.
Okay, ma'am. Is my PPT visible, ma'am?
Yes, visible. You can start your presentation.
Okay. Good afternoon, everyone. My name is Munnaram Seni. I am research scholar in Jaipur National University. In this conference, my topic is selective synthesis of novel spiroindenoquinoline pyrrolidines by 1,3-dipolar cycloaddition reaction. My presentation mainly divided into 3 parts: introduction, resultant discussion, and conclusion. First, introduction. Dispiroindenoquinoline pyrrolidines skeleton have attracted much attention in synthetic organic chemistry due to their remarkable presence in wide variety of pharmaceuticals and naturally occurring alkaloid that exhibits diverse bioactivities. For oxythiazolidine, yelidine moiety is very interesting to further organic transformation due to the presence of activated extracyclic carbon-carbon double bond, and so it acts as dipolar to construct spiropyridines. Inspired by all above mentioned facts and as our continuing effort to the construction of dispiropyridine, we report herein the radioselective synthesis of amino thiazolidinone appended novel dispyro-indenoculinogen pyridine via a multi-component 1,3 dipolar cycloaddition strategy. Here is the reaction scheme. Now result and discussions. Firstly, we synthesize starting materials 1 and 2 dipolar labeled by 1 synthesized by the reaction between substituted thiourea and DMAD, and starting material indenoculinogen labeled by 2 synthesized by diamine and enhydrine by a condensation reaction. By using starting material 1, 2, and 3, we start the synthesis of spiro indenoculinogen pyridine labeled by 4. Starting material 1, 2, and 3 we were chosen for 3-component reaction and refluxed the equimolar mixture of all the substrates in different solvent to find the best results. Results for various solvent we can see in the table. Here the product selectivity was not influenced by the nature of solvent and mode of heating, as the same single isomer was obtained regio and distereoselectively in all conditions. Present 1,3 dipolar cycloaddition reaction proceeds smoothly with chloro, chloro, difluoro, methyl, and bromo substituted dipolar files, but failed in case of NO2 substituted dipolar file, as we can see in the table. Now conclusions. Desired product dispyro-quinogen pyridines were obtained in good yield 80 to 90% with high ratio and stereoselective manner. The generation of up to 4 new contiguous stereocenters and formation of 2 carbon-carbon double bond and 1 carbon-nitrogen bond in a single formation were observed. All the products characterized by mass, single crystal XRD, and NMR. Here is the crystal structure of a product you can see below. This work has been accepted for the publication in the chemistry select. Thank you for your time.
Any questions from participants? If there are no questions from participants, I thank Mr. Munna Ram Saini for your nice presentation and nice work. Thank you, Dr. Munna Saini. Next presentation is OVO 25. Manjunatha B.
Yes, sir.
Available? Okay.
Yes, sir.
Share your presentation.
Yes, sir. It's visible, sir.
Not yet. Now it is visible.
Okay. Myself, good afternoon, everyone. Myself, Manjunatha B. Presently, I am pursuing PhD under the guidance of Professor Yadav D. Bodke, Coimbatore University. My oral presentation entitled BSc, that is bovine serum albumin mediated efficient one-part synthesis of some bis 4-hydroxy 6-methylpyranone derivatives and their biological studies. Okay, my contents of the presentation include introduction, spectroscopic characterization, biological studies, and molecular docking studies, conclusion, and references. Coming to introduction, biocatalysis is a very potential tool in organic transformation, which meets the concept of green chemistry and atom economy. BSA is known for a catalytic promiscuity towards various organic reactions such as nitro-aldol condensation, Michael addition, Bigenelli reaction, and Noven-Nagel reaction, etc. And also, these multi-component reaction exhibit very good contribution towards green synthesis by reducing the number of workups, extraction, purification process, and also allow the formation of several bonds in a single operation. So these are very important in the aspects of synthetic chemistry. And also pyran derivatives are an versatile, very good heterocyclic scaffold found in many natural products and pharmaceuticals. These pyran and pyran unrelated some heterocycles are act as versatile intermediates in organic synthesis, medicinal industries, agrochemical industry. These are also known for their very broad range of pharmacological activities such as antimicrobial, anti-inflammatory, anti-convulsant, anti-HIV activities, etc. Okay, coming to present work. In this work, we have developed a simple, convenient, and environmentally safe method for the synthesis of these 4-hydroxy-6-methylpyran derivatives, and studied their biopotency towards antimicrobial and anti-inflammatory activity, and also studied their in silico studies with the COX-2 receptor. Okay, this is an reaction scheme. In this scheme, we have utilized one equivalent of different substituted aldehyde and two equivalent of 4-hydroxy-6-methylpyranol. Then, in the presence of BSA 10 mg, but for in an ethanol solvent at 45 degrees centigrade, we have achieved this product formation. Also, synthesized these synthesized products are characterized by various number of spectroscope technique like IR, NMR, mass spectroscopy. Okay, in IR spectroscopy, this is an IR spectrum for a compound 3A. In that, the peak at 1678 per centimeter corresponds
Mr.
to
Manjunatha,
yes, sir.
share your slides. Still, we are seeing only first slide.
Sorry, sir. Sir, now, sir.
From scheme onwards. Yes.
Yes, sir. Okay, this is an LCMS spectrum of the compound 3A. In that, the peak at 1678 centimeter correspond to this carbonyl group. Then the OH frequency resonated at 3418 per centimeter. Then an aromatic stretching appeared at 3063 centimeters. This is an proton NMR spectrum of the compound 3A. In that, in proton NMR, this junction CH appeared at 5.726 ppm as a singlet. Then the methyl proton resonated at 2.27 ppm. Then the OH appeared at 1.84 ppm. Then aromatic protons appeared at 7 to 7.259 ppm as a multiplet. And this is an C13 spectrum of the compound 3A. In that, the carbonyl peak resonated at 170 ppm. Then the carbon attached to oxygen appeared at 161 ppm. Then further peaks are correspond to aromatic proton, and also the methyl proton resonated at 19.66 ppm. This is an mass spectrum of the compound 3. In that, we got a M+H peak at M by Z 384. This the antimicrobial activity results of the synthesized compound. Among this compound 3B containing a nitro group showed a very good activity against various bacterial strain. Then this is an anti-inflammatory activity of the synthesized compound against MMP2 and MMP9 derivatives. Among the synthesized compound 3D and 3G showed very good activity against MMP2, and also all the synthesized compounds showed a moderate activity against MMP9 protease enzyme. This is an gelatin zymographic image. Then coming to molecular docking results of the synthesized compound, we have carried out the molecular docking study with a COX-2 receptor. Among this, the compound 3B containing a nitro group showed a very good binding affinity, that's an -9.2 kilocalorie per mole by forming one nitrogen bonding, and the remaining compound also showed some appreciable interactions and binding energy with the COX-2 receptor. And then these are the 2D and 3D interaction of the synthesized compounds with an COX-2 receptors. This one also 2D and 3D with COX-2 receptor. Then coming to conclusion, in this research work, we have explored some catalytic behavior of the BSA by synthesizing this 4-hydroxy-bisphenol derivatives through novel condensation and followed by Michael addition reaction. This synthesis met the green chemistry by involving a simple operation, simple filtration without extraction or column chromatography. From the antibacterial activity results, it's evidence that compound showed a very good efficacy, and also this act as a very good anti-inflammatory agent, and also it showed a very good interaction with an COX-2 receptor. These are the references. Thank you.
Any questions from participants? If there are no questions from participants, thank you, Mr. Manjunatha B, for your nice presentation and nice work. Convey my regards to Professor Yadav B. Bodke, sir.
Okay, sir. Thank you.
This is Professor Ashok.
Okay, I will tell this. Thank you.
Next presentation, OVO 26.
Yes, sir. My name is Kapil Dhawan, sir.
Okay. Yes. Please share your presentation.
So, am I audible and
yes,
if it is visible, sir?
Yes, yes, you can proceed.
Thank you, sir. Good morning, everyone, sir. My name is Kapil Dhawan and I am PhD research scholar, Jaipur National University, Jaipur. Sir, so I would like to present my work on the topic greener synthesis of dipyrimidines using EGTiO2 nanocomposites as heterogeneous catalyst. I am doing my research work under the supervision of Professor Ruby Singh. She is the professor in Jaipur National University, Jaipur. So my work is basically on the heterocyclic synthesis, and I will present my work here, the synthesis of dipyrimidines and the contents of my work. These are the nanocatalyst and introductory part, and the preparation and mechanism of nanocatalyst, and the spectra regarding UV visible, FTIR, SAM images, and the synthesis of my heterocyclic compound, that is the dipyrimidines, and the model reaction and mechanism of the synthesis of this compound I will show here. And the nanocatalysts are the combining different materials to develop new matrix materials, and one of the components has at least one dimension at around 10 to the power 9 meters. And nanocomposites should have the multiple application in industrial and medicinal fields like biosensors, batteries, photovoltaic cell, electrical devices. I have used the EGTiO2 nanocomposites. As we know, there are so many nanocomposites of TiO2 like Al2O3, Aurum, Gold, PT, CU2, PD. But I have used EGTiO2 nanocomposite because it has the best results to synthesize the heterocyclic compounds like high surface to volume ratio, increased dimensional stability, improved mechanical strength, higher chemical resistance, and higher electrical conductivity, low cost and low toxicity, and so on. And these are the nanocomposites. And what is the mechanism proceed to synthesize this nanocomposite EGTiO2? First of all, I take the TTIP, that means the titanium tetraisopropoxide, and AgNO3, and I have and the TiO2 nanocomposite is formed. And this is the UV visible spectrophotometer. This 380 nanometer range absorption band is observed at in the UV visible spectrophotometer, and 570 nanometer band band at around 570 nanometer is due to the localized surface plasmons, that is the LSPR. And this is the FTIR spectra of AgTiO2. And these are the XRD images and SAM and TEM images of AgTiO2. And you can see that in EDS mapping, this is the titanium, this is Ag and oxygen element are present in AgTiO2 nanocomposites. And finally, I have synthesized this the compound fused compound by the multi-component reaction, or we can say that 3-component reaction by using the 1,3-dimethyl barbiturate acid and uracillamine and various aldehyde, various benzaldehyde in the using the water as solvent and under sonication. And what is the mechanism behind this? First of all, this 1,3-dimethyl barbiturate acid react with the aldehyde, and here nominal condensation takes place, and this intermediate is formed. And after that, this intermediate react with the uracillamine and form this intermediate. And here and after cyclization, this fused compound is formed. That is the pyridodipyrimidines. And the comparative comparative study is this AgTiO2 nanocomposites. When we use this AgTiO2 nanocomposite, then best results are formed and 91% yield obtained. And advantage of the processes are these are the advantages: short reaction time, cost effective synthesis, easy workup process, recyclability, catalyst manufacture of nanocatalyst does not need expensive synthetic procedure. These nanocatalysts have high TOF and TON value. Thank you. Any questions, sir?
Any questions from participants? If there are no questions, thank you, Mr. Kapil Dhawan, for your nice presentation and a nice work. Next presentation is OO27 G. Simhachalam.
Yes, sir, I am available.
Oh, yes. Please
okay,
share your presentation.
Sir, is it visible?
Yes, yes.
Okay, sir. Yes, sir. Good morning, respected professors and participants. Myself, Simhachalam. I am working in R&D, Dr. Reddy's Laboratories, under the and I am doing my PhD under the guidance of Dr. L. Vaikuntrao sir, Geetham University, Visakhapatnam. The title of my work is acetic acid catalyzed synthesis of novel imidazo 1,5A quinaxilines and spiroimidazo 1,5A quinaxilinones from inactive 2,1H imidazole 1-aryl aniline via Pickett-Spengler reaction. This is the scheme, and I prepared this 2-amino starting material 2-amino this one imidazole from 1-fluoro-2-nitrobenzene by using imidazole and followed by reduction. Next, introduction. We all know that quinaxilines are the complex of two rings, benzene and pyrazine. So it is called benzopyrazine, and there are 4 types. One is pyrrole 1,2 quinaxilin and indole quinaxilin, and in imidazole there are two types, 1,5 and 1,2 phenylaxylins are there. As Gopala sir also earlier told, phenylaxylins are very important nitrogen containing compounds that displays useful psychological effects and wide spectrum of biological activities. Among them, imidazole and spiroimidazole are fused ring system which contains both imidazole phenylaxylin as well as indole in one moiety, and they exhibit the potential anti-tumor, antifungal, and anti-HIV, and so on. So all these superiorities appeal the continual attention of the research on the intensive studies. These are the some of the important biologically active imidazole units in the found in the literature. So the general mechanism is the general strategy of the Pickett-Spengler reaction. First one, and I said the starting material is inactive because the electron deficiency in the imidazole ring, so it is unreactive generally. And if you have any electron releasing groups at second position or fourth position, it is moderate reactive. If we have both the if you have any electron releasing at both the positions, second and fourth position, that is highly reactive. Whatever the literature, whatever the previous literature, if you see, there is no reports, direct reports to prepare these imidazole phenylaxylins from straightforward by using benzaldehydes. And if you see in the first one, 4-chloro-phenylaxylin, this was prepared, phenylaxylin, four substituted phenylaxylin is prepared by Suzuki coupling. And in second reference, if you see, it is the multi-component reaction is there. In third one, it is the Verma and all reported. In this, if you have see the R1 and R2 is suppose hydrogen, there is no reaction in this. If you have methyl or ethyl, then the reaction is very fast. And in the fourth one, if you see only resin bound, if you have resin bound and the releasing groups are there in imidazole ring, then the reaction will be complete. And we have to use 20 equivalents of aldehydes, and the reaction time is also very long. So I started feasibility of this reaction with some of the catalysts like tributyl tin molybdenum oxide, as I used in the paper in my paper. But you in and beta CD, beta cyclodextrin, and this one only formed this intermediate imine 3. But I tried with this one TFA 10%. In this only one non-polar spot was formed. That was isolated and checked. That is cyclized 1,4. It is only 10%. Then I screened different this one 50% across HCl, but there is no reaction. With the acetic acid, surprisingly, after 1 hour, this intermediate 3 is there, and after 3 hours, I found intermediate this cyclized product 4. If you maintained further that one for 20 hours, we found that this our desired product 5 was formed around 85%. It is somewhat longer time, so that I introduced the oxidant in acetic acid after completion of 3 hours. We externally added oxone, 2 equivalents in this. At that time, actually the reaction was completed in 5 hours, and the yield is also 90%. Then I screened oxone 1 equivalent and 3 equivalents, but the yield is 90% only. So I optimized the reaction conditions is in acetic acid at reflux 120 degrees centigrade, and oxone 2 equivalents. I optimized the reaction conditions. Then I made, these are the 11 compounds, phenylaxylins I made only first one is the known, remaining one all are unknown compounds, and these are the one equivalent of starting material 1 and one equivalent of aldehyde in acetic acid 120 degrees centigrade maintained 3 hours. After that I added oxone to complete the oxidation. And all these compounds are actually characterized by using proton NMR 13 C13 NMR and HRMS and IR. And these are the imidazopinacillins. Surprisingly, there is no reports on this. First time I am reporting this imidazopinacillins. With the same conditions, I taken this substrate 1 and I prepared different substituted unsubstituted isotins, and the same conditions I did. And here there is no column purification also. In acetic acid, I added water and filtered the solid, and that filtered, if you have any trace of acetic acid is there, then I slurried in water actually. This is the possible mechanism. First, that aldehyde is protonating by acetic acid, and that protonated acetic acid is attacked by the amine group of the starting material, and it is forming Skips base 2 after removal of water molecule, and then cyclization giving this secondary carbocation. After aromatization, it is coming the dihydrophenolactone. Then oxidation of the dihydrophenolactone, we are getting final desired product. These are the conclusions. In summary, we are successfully demonstrated the synthesis of imidazopinacillins and spiroimidazopinacillins using acetic acid from the inactive and electron deficient starting material in good to excellent yields, and the spiro imidazopinacillins are first time demonstrated, and it is atom economic, and the more substrate scope is there. Thank you. Any questions?
Any questions from participants? Anybody? If there are no questions, I thank Mr. Simachalam.
Thank you,
for
sir.
your nice presentation and nice work.
I am very thankful to ICC and Satavahana University and all.
Convey my regards to Professor Vaikunta Rao.
Thank you, sir.
Your guide.
Sure,
Sure, sir. This is Professor Ashok.
Sure, sir.
Okay, thank you.
Thank you.
Next presentation is O28. Neha
Yes.
Tiwari.
Yes,
You're
sir, I am
available.
available.
Yes, okay.
Sir, slides are visible?
Not yet.
So slides are visible?
Now visible.
Now is it visible? So may I start? So may I start my presentation? So slides are visible?
Slides are visible, yes.
Good afternoon to all. Myself Neha Tiwari. I'm doing my research work under the supervision of under the supervision of Dr. Savita Khare from School of Chemical Sciences, Indore, Madhya Pradesh. Today I am presenting my research work on oxidation of ethyl benzene over new heterogeneous catalyst. The next slide is based on introduction. Metal catalyzed system for CH bond activation of alkanes is a field of academics as well as of industrial importance. Oxidation of ethyl benzene is an important industrial process. The major oxidation product is acetophenone. Acetophenone is used as a component of perfumes and as an intermediate for the manufacturing of pharmaceuticals, resins, and alcohols. Earlier, shear bases were used as a homogeneous catalyst, which gave good conversion, but this system became less preferable due to some drawbacks like non-reusability, difficult product separation, etc. To improving these drawbacks, we have prepared chitosan-supported heterogeneous catalysts for ethyl benzene oxidation. The next slide is based on application of oxygenated products. By the oxidation of ethyl benzene, we have obtained two products, acetophenone, benzoic acid. The first product is acetophenone. Acetophenone is used in fragrances, in soaps and perfumes, and as a flavoring agent in foods, and as a solvent for plastics and resins. And the second product is benzoic acid. It is used in the production of dyes, topical drugs, perfumes, and insect repellents. It is also used food pH adjuster and a preservative. And the next slide is based on synthesis of our cobalt catalyst. We have chosen anchoring method for the preparation of our catalyst. We have prepared our catalyst in 3 stages. In the first,
share your other slides.
Okay, sir.
Yes.
We have prepared. In the first stage, we have prepared heteroligand by treating cytosine.
Still, we are seeing only first slide.
So, is it visible or not?
Visible only first slide we are seeing. Move your slides.
Sir, I think so. It's a network issues.
Oh, nice.
First of all, in the first stage, we have prepared heteroligand by treating chitosan with orthohydroxyacetophenone, and after this, we have prepared homoligand by treating aniline with orthohydroxyacetophenone. After the preparation of both ligand, we have prepared our catalyst by we have treated both ligand with cobalt salt, cobalt chloride, dihydrate. And the next slide is yes, sir.
Neha, please move your slides.
Sir, I have moved. Sir, I have moved.
But we are unable to
see. You are not moving it. Something is there. Something you just click it on, then you can move.
Sir, I have moved. Actually, ma'am, I have moved.
No. See, that is some highlight. Something is blocking. You just click it on the same slide, then or come out of that slide and click it.
Now okay.
Okay, sir.
Yes, okay.
Okay.
The first slide.
This slide is based on characterization of heterogeneous catalyst. In the first graph, the first figure shows the XRD patterns of chitosan and our catalyst. In the XRD pattern of chitosan, there are 2 peaks appeared at 9.27 and 20.29 degree angle. But in XRD pattern of our catalyst, these peaks are shifted to 16.87 degree angle and 32.29 degree angle. And the intensity of all peaks and crystallinity of material also decreases. Thus, it shows that the coordination of cobalt ion with modified chitosan takes place, and the spacing and particle size is also calculated for chitosan and our catalyst. The d spacing are 9.63 angstrom and 5.5 angstrom, and the particle size are 0.42 nanometer and 0.61 nanometer. According to the particle size of our catalyst, we can say that the particle size of our catalyst increases as compared to chitosan due to some chemical modification on chitosan surface. And the next graph is sorry. And then the next figure shows the FTIR spectrum.
Neha,
Yes, sir. Yes, sir.
We are unable to see your slides. Only.
Sir, I think so. It's
only characterization of heterogeneous catalyst.
This is the FTIR spectra.
That slide only we are seeing.
Slides are not moving.
You selected something.
Selected something. Yes. Click
the second
figure.
Second figure,
The box you click.
second figure shows that the
You
FTIS
should have gone for a
spectrum
slideshow
of
actually.
our catalyst
Go
on
to
comparing the
slideshow.
Go to
data.
slideshow, ma.
Go to slideshow.
Ma'am, is it visible? Characterization of a
No.
heterogeneous catalyst.
It's
On the
okay.
top,
Okay.
you go to slideshow. Okay. Click out of the box. Then you can
Move the slide.
ఇది కొట్టింది అందుకే అది కదులుతుంది
ఏది
హైలైట్ అవుతుంది డబ్బలాగా
You are highlighted something, amma.
FTIS spectra. Sir, can I explain?
Okay, okay,
The
proceed.
slide.
Okay.
The second figure shows that the FTIS spectrum of cytosine and catalyst. On comparing the data of cytosine with catalyst, the new additional peak appear in catalyst at 1644 centimeter inverse. And the third figure shows that the TGA thermogram. The TGA thermogram of cytosine shows the final weight loss occurs at high temperature, 300 to 400 degrees centigrade. And the TGA thermogram of our catalyst displays the final weight loss occurs at 200 to 300 degrees centigrade. According to TGA thermogram, our catalyst is stable up to 200 to 300 degrees centigrade. Next, the SAM image of cytosine displays the flaky nature, even and a smooth surface. In the next SAM micrograph of catalyst, the roughness observed on the surface of catalyst demonstrate the chemical modification of cytosine surface due to intercalation of ligand 1, ligand 2, and cobalt ion on the surface of the modified cytosine. The EDX data of cytosine and our catalyst shows in the table. The EDX spectra of complex shows the presence of cobalt ion in the matte complex. And the next slide is based on catalytic oxidation of ethyl benzene. Our catalyst is suitable for the ethyl benzene oxidation. The catalytic oxidation of ethyl benzene have done by 1:3 molar ratio, substrate to oxidant ratio in acetonitrile solvent for reaction time 5 hours at 80 degrees centigrade temperature. The two products are formed like acetophenone and benzoic acid. Both products are very useful for industrial background. And the next slide is based on optimization of the reaction condition for the oxidation of ethyl benzene. We have studied different parameters like oxidant ratio, catalyst concentration, temperature, time for ethyl benzene oxidation. After this, we have choose oxidant ratio 1:3, temperature 80 degrees centigrade, catalyst concentration 50 mg, and time 5 hours are optimum for ethyl benzene oxidation. And our catalysts have recycled about 7 times without any leaching. The last one slide is conclusion. Cytosine supported heterogeneous catalyst has been synthesized by anchoring method. This catalyst is analyzed by XRD, FTIR, SAM, EDX, TGA, etc. The catalytic system, our cobalt catalyst with 70% TBHP have studied for the oxidation of ethyl benzene. Under optimized condition, the maximum conversion 39.88% of ethyl benzene oxidation was obtained. The two products with acetophenone with 85.30% selectivity and benzoic acid 14.70% selectivity are obtained in ethyl benzene oxidation. The major product is acetophenone. All the products have many industrial applications. The catalyst is recycled 7 times for the oxidation of ethyl benzene. The catalyst is fantastic in the sense of the stability, activity, and reusability. Acknowledgement. I am very thankful to Almighty God, my parents, and my supervisor, Dr. Savita Khare ma'am, Head School of Chemical Sciences, GAVV Indore, UGC DAE Consortium of Scientific Research Indore. And I am also very thankful to ICC for giving this opportunity to present my work. Thank you so much.
Any questions from participants? If there are no questions, thank you, Neha Tiwari,
Thank
for
you
your
so
nice
much, sir.
presentation. Nice work.
Thank you.
Thank you. Next presentation is OO 29 B Gautam. OO 29 B Gautam, Nawadal Haq and Rajesh Kumar. Gautam, are you available? No. Next presentation is Dr. D.N. Singh. Are you available? Anybody is ready to present? Participants? Yesterday, those who are not presented, today morning, those who are not presented, they can present now. Anybody is available to present their research work? G. Prabhakar, GVR Sai Madhukar, P. Ravikumar, Muhammad Khadir, Ramesh Domala. OO 08, Prakash Ram, Arun Kumar. OO 13, D.N. Singh and N. Verma. OO 20, Nisha Verma and D.N. Singh. OO 23, S. Ramkumar and R. Rajalakshmi. Dr. D.N. Singh, are you available? OO 29, B. Gautam. If there is no response from absentees, we will close within 5 minutes. Valedictory session will be at 2 p.m.
Sir, all sessions
It's almost over, but some are absent.
Okay, sir. Okay, no problem.
Thank you, sir, for participating in organic section.
And the organic strength బాగుంది కదా సార్. That's what.
Along with Subhash madam. Along with Subhash madam.
Yes. Okay, sir. So all sessions are over, sir. Inorganic, physical, and others also.
And just that I have to inquire. I think almost over because in organic only highest number of presentations are there.
Then it's okay.
And 2 o'clock valedictory, sir.
I'll join, sir. No problem.
Yes, for valedictory, link is inaugural link.
Which one, sir?
Inaugural link.
Inaugural link. Okay.
Inaugural link.
Okay.
Inaugural link undi sir.
Yes.
Okay, sir. Thank you, sir.
Hello.
Thank you. Good. Participants, 20 participants uన్నారు. Anybody is ready to present? Absentees? If nobody is available to present, we'd like to close the session. I thank Sectional President Professor Lilavati Garu for nicely conducting sessions for both the days. And I thank all the invited speakers of organic section, chairpersons of the sessions, CYSA presenters, and organic borer presenters, and all the participants who involved in organic sections. Thank you very much. Organized secretary. If there are no presentations, we'd like to close the session. Dear participants, thank you very much for your active participation in organic section. I thank sectional president, chairpersons of the sessions, and all the presenters, CYSA and oral presenters. Thank you very much. Now I'm closing organic session. Thank you very much. Leave
Vodafone.